All right, guys, we are live. Here we are. My name is Nathan, otherwise known as Old Man Bills. We got Benefactor here. Gerald's here. We also have Crypto here. And we have our special guest, Shawn Calderon. Shawn, how you doing?
I'm doing great, Nathan. Thanks for having me.
Yeah, not a problem, man. We're all checking out your coils there, man, and they're just awesome. Everybody's been waiting for this.
I appreciate that.
So check it out. Shawn's got some stuff to present. I'm going to bring it up. Shawn, if you want to get into it, if you want to say anything, by all means, let it happen.
Awesome. Sounds good. Hey, apologies for not having video ready. I had to kind of throw some stuff together just to get the audio working. So I'll be the talking still pick during this presentation. So thanks a lot, Nathan. I met Nathan a couple months ago. He was working on a Tesla coil as I was, and I had sent him some video clips of what I was working on. And Nathan, he basically took my little cell phone clips and put them together and made quite a montage. And that's really the impetus for me doing this presentation and entering YouTube world. So I put together some slides and a few video clips to just talk about what I'm doing. Before I get started, when I was in the Navy, I was a trained electronics technician, and I was electronics technician on the USS John Paul Jones for 6 years. After that, I did a tour of drill sergeant duty for 3 years. After I got out of the Navy, I taught myself how to compute a program and began my career in pharmaceuticals. I ended up staying in IT for about 17 years before an early retirement. And it hasn't just until recently that I've started this hobby. About 14 months ago, I decided to pick up the soldering iron again and get back into designing electronic circuits and working with electricity as I did about 28 years earlier. And I unfortunately couldn't recall most that I'd learned in the Navy. So I needed a book to get started. And I found this book here you can see in the slide 1. And this book is really good for 2 reasons. One, it gives you a really good introduction to the topic of electrical engineering, but it also is a good reference book so you can always refer to it when you have questions about building your circuits. So I thought I'd share that before I get into the stuff that I'm working on. Next slide, please.
Yeah, that'll probably help, man, if I go to do that. Hold on. There you go.
Awesome. So what I wanted to do to get into the hobby of electrical engineering was I wanted to create high voltage. And so as I was researching the topic of high voltage, of course, the famous and infamous Tesla coil came up. And this really excited me. Here you could have something you can plug in and it can throw lightning bolts. And so I ordered one from China. It was a kit and it looked something like this. And when I got it running, the first thing I noticed was it was extremely loud, obnoxiously loud. The second thing is it had a few ways where if you touched it, you could be electrocuted seriously. So it was dangerous. It was loud. And then thirdly, it was creating a lot of ozone. It was creating a lot of nitrous oxide and other dangerous gases as it was throwing lightning bolts. And then lastly, I just thought they were ugly. They all look the same, like this. And so I thought, well, maybe I can do a different take on Tesla coils. And so what I did is I started to design my own Tesla coils, and it starts with the ZVS circuit. Next slide. The humble ZVS circuit. You can buy these from Amazon. They run you about $27 right now. And yet this circuit is an amazing, amazing system. For general purposes in this presentation, I'd like to just introduce it as the high voltage oscillator. That's what it is, a high voltage oscillator. And it's very efficient, so efficient that when you're using it, you really don't have to worry about cooling or your power transistors or your MOSFETs burning up. So this is the circuit that I will be using throughout all of the presentations and videos that I'll be sharing. In fact, that intro video, I was using this same exact circuit for every Tesla coil that you saw. So this is the circuit that I use, except for I take off the capacitors. And the reason for that is the circuit has too much capacitance in order to be used for a Tesla coil. That's the only reason why the capacitors go. Next slide. I was asked by Charlie C, why do I use the ZVS circuit and not other circuits? Well, there are a lot of plans, a lot of diagrams, a lot of circuits, a lot of schematics on the topic of Tesla coils. But the reason why I use the ZVS is, one, it's very simple. It only has 12 components, and you can even get that down to 10 components. So it's simple. That makes it easy to build. That makes it easy to troubleshoot. Another reason is it's very powerful. Some of the clips I'm going to share with you, it's going to be pumping out 1,000 watts. Yes, 1,000 watts for a little 6-inch coil. It's pretty amazing. It's rugged. I can beat it up all day and it'll still work. And it can do a lot more things than power Tesla coils. And so if I have the opportunity to share again a presentation on Nathan's channel, I'll show you some of the other inventions that I'm using it for. Next slide. When you think of the ZVS, you need to think of it as a high voltage oscillator. And then when you want to figure out the frequency that it's going to oscillate, you only need to think of two things: the capacitor and the coil. That's all you have to be concerned about. It is what is called an LC tank circuit. If you figure out your capacitance, if you figure out your inductance, then you can just plug that into any frequency calculator. There's a lot of free ones on the internet. Then it will tell you the frequency of your ZVS oscillator. I kind of simplified it here so where it's just completely bare bones. When you look at prints and see videos on the ZVS, they're all overcomplicated in my book. They're just people like to make simple things hard. So always be thinking about these two values, and then you will be able to control the output of your ZVS. Next slide. Here's a calculator that I found online. I plugged in the 4 nanofarads for the capacitor. I plugged in the 4 microhenries for the inductor, and I ended up with an output frequency of 39 megahertz. Now that is way too high for a ZVS to handle. The range of frequency for the ZVS is around 25 kilohertz all the way up to about 500 kilohertz. Those are the ranges you want to stay in, because those are the limitations of how fast the MOSFETs can switch, how fast the diodes can switch. And so because of that, it's not able to perform in the megahertz range. And if you find a ZVS that can perform in the megahertz range, please tell me. That would be awesome to see. So it's really that simple now. You have control of your ZVS if you control these two values. You can determine its frequency by controlling these two values. Next slide. So when I built my first ZVS Tesla coil, here it is on the screen. You can see that the ZVS is on the lower left. You can see that copper tubing that wraps around the red cylinder. That's the primary coil. And then the red cylinder in the middle is the secondary coil. And if you look at the tip there, the copper tip there, you'll see a little breakout, a little purple flame. And this was my first time getting a ZVS circuit working for a Tesla coil. So it was just a really amazing breakthrough for me to now start down my road of leveraging the powerful ZVS. Next slide. In the background on the oscilloscope, you can see how the ZVS is powering the Tesla coil. The frequency S wave, you can see there, the sine wave in yellow is the pulse that is going through the primary coil. The green signal, you'll start to see it as a line, and then it works its way up and down till finally it builds momentum at the end. That is the secondary coil working its way toward a resonant frequency, so then it can output that purple arc out the tip there you're seeing on the screen. Now, this is what's happening at 300,000 times per second. It's doing this inside primary, secondary frequency or resonant frequency output. Next slide. So that's just another close-up. You can see the primary frequency doesn't really change in amplitude, but the secondary frequency starts to build up from left to right, and then it discharges, and then it starts all over again. Next slide. This is what your ZVS looks like if you're not shortening your leads. All of the leads that connect things up in your circuit, if they're too long, you're going to pick up noise and get this distortion. And so when you're putting together your ZVS, it's good to have short connections to the capacitors and the coils. Next slide. So what I've done is, instead of winding a Tesla coil with one layer of copper wire, I 3D print a cylinder with deep grooves. And then inside those grooves, I can wrap anywhere between 15 and 100 winds of coil. What this allows me to do is I can have a 3,000 wind coil or a 5,000 winding coil, and yet my coils don't get taller or longer than 6 inches. The coil you'll see here on the screen is 6 inches, so it's the biggest coil that I've wrapped. And when you're watching the video clips of how these coils perform, please know that these are very small coils, even though they're throwing out 10, 12, and 18-inch lightning bolts. Also, one more real quick tip. Because I deal with, I buy wire, magnet wire in bulk, I went to the thrift store and picked up a record turntable, and then I center this 20-pound spindle of wire, and it takes like milliounces to wind my coil. No strain at all. So I'll just put in my favorite YouTube channel, one of Nathan's videos, and I'll start winding. Next slide. So once I've wound the coil, I place it into a form so that it's ready to be poured in epoxy. Next slide. Once that the epoxy has been vacuumed, so the bubbles are removed, I then give it about 3 days to cure, and then I'll open it up to remove the form. The form doesn't stick because I use Vaseline, and the epoxy does not adhere to the Vaseline. And so then inside, what you have is a Tesla coil. This here, the one you're seeing here, has 5,000 turns of wire. It's only 6 inches long, and yet it is completely infused with 2-part epoxy with no bubbles. Next slide. This is a picture of it. You can kind of see that there's a slit on one side of the coil, and this allows me to, once I've completed one ring of windings, I can then switch to the next ring, and then to the next ring, and so on. And so that's what you're seeing here. Next slide. Here I'm kind of rolling it because it's really hard to see with the photos, but it's completely translucent. You can see just the it's like almost like a sculpture, the way the light refracts inside, and it almost looks like gold. So there's an aesthetic quality of winding these that I love. Next slide. Now we're going to get to the Death Star. So I've applied the same principles to the cylinders that I've wound to a sphere. And so here you could see a grooved sphere. And also I'll mention this, every object that I wind in this way has 100 grooves. And that just makes it real easy to now know your turns. So if I put, let's say 25 windings per groove, at the end when I'm done, it's going to be 2,500 windings of wire. I'll have to give a shout out, Brian Brum. He's a CAD genius, and he's helped me so much in getting these 3D prints. Next slide. Again, now you can kind of see inside what it looks like. Next slide. Next slide. So this took quite a bit of time to hand wind. My eyes kept going cross-eyed because I would end up with the sphere playing sort of optical illusions on me. But I was able to complete it. And the end total was 3,000 turns of wire, and the diameter is 4 inches. Next slide. Now it's time to put it in the form. The reason why the form is multicolored is that I kept running out of filament in my printer. So basically it started out red, and then I ran out of red, put blue, then I ran out of blue, and then went to green. So it's colorful, but not on purpose. Next slide. Here it is, ready for the vacuum chamber. Next slide. Here, when I've peeled it away and taken it out of the vacuum chamber and I clean it up, it's having that amazing translucent clear coating, bubble-free straight through the sphere. And you can see that the sphere is fitting in one hand, so it's about twice the diameter of a billiard ball. Next slide. Here are all the parts that I'm going to put together. So if you want to screenshot this or watch this later and screenshot, it's really simple. The ZBS coil, a couple alligator clips, some 1/4 inch plumbing copper wire, and some capacitors, and you're ready to go. I put the lighter in there, but you can't really see it, to try to give you scale, but the lighter is 3 inches and the ball's 4 inches. So just to show you how this is not that big. Next slide. When I first started testing the sphere, I had to, if you could see that right there, when it discharges on the primary coil, that's actually a bad thing, even though it looks really cool. And what's happening is that the plasma discharge is just bursting through the 2-part epoxy and grounding itself out on the secondary coil. And that's just not desirable because it'll start burning up all my work. But it looks pretty cool while you're setting it up. The flashes that you're seeing there is the vaporizing of the epoxy at temperatures that equal the surface of the sun. You can actually Google that. Plasma is a pretty awesome, powerful thing. But this is what an untuned working prototype looks like before it gets tuned. Next slide. And so we're going to start now watching videos of it as I begin to tune it. And when I say tuning it, what I mean is I'm bringing it to the resonant frequency of the sphere. The sphere's resonant frequency is 101 kilohertz. And so what I do is I try to adjust the capacitance, those capacitors over there on the left, to get as close as I can with the primary coil to equal the secondary coil's resonance. Now, what you're seeing here is you're seeing about 1/3 to a quarter to a third the size of the Death Star, and that is what is called a quasi-continuous wave. Quasi-continuous wave is my favorite output because it's just real fluffy. It's really intense. When I first tested this, I was about 10 inches away, 12 inches away, and it singed my eyebrows. And the video doesn't do it justice. There's just so much power coming from this continuous wave. We're looking at about 7 or 8 amps, and it's just incredible. Also, too, I'll show you later, but when I take an infrared picture of the ZBS, the MOSFETs are cool. Okay, so nothing's overheating on this circuit. And the only thing that's overheating is that if you walk in proximity to that continuous wave output, man, it's just amazingly powerful. Next slide. So now this input is different than the previous input. The previous was just a DC input. This input is an AC input where I use one diode in order to partially rectify the AC. And so what's the input is just a bunch of, it's a pulsing DC. What's fascinating about this one is it has a completely different discharge. Instead of the big fluffy ball, it basically outputs these very fractal-like lightning structures. It's hard to see in here, but we'll see it a little bit. But the diameter of these arcs are about 3 times the diameter of the Death Star, and that's amazing. It's also doing something that I didn't expect, doing the opposite of, I guess, the intuition. And what it's doing is the more I tune it, the more I get it closer to the secondary resonant frequency, the less radiant energy it has to power up anything wirelessly. So, you've seen the Tesla coils where they'll take a little neon bulb and they'll bring it over to the Tesla coil and it'll light up. The more I tune this Death Star, this sphere, the less you can light up those neon light bulbs. It's working so efficiently, this little ball of wire, that it is pushing out all of its energy out through the arcs and sparks, as you're seeing here. And I'll give you an example of that here in one of the future clips. Next slide, please. This is a bit tough to see. Let me see here from my screen. Okay, so I'm just going to provide some clips just to kind of show you how the more I fine tune it, and I'll explain to you later what fine tuning is, more and more power is coming out of it. Now, if you notice, there was some sort of lightning bolts coming out of the fluff. One of the things about these Tesla coils is that when you start cranking up the voltage, what will happen is that you'll reach a point where there'll be maximum spark output. And then if you go past that point and add more power to it, it'll actually start reducing again. So that's interesting to me. You would think that it would just keep growing until something blew up, but that's not the case. So once I get it to about 40, 45 volts, all of a sudden, if I hit 50, 55 volts, it starts shrinking again. And so that's another phenomenon that I wanted to share here that's very interesting because I didn't expect it to be doing that. Next slide. And I appreciate everybody's patience. We're about halfway through, and then it'll be wonderful to take questions. This is just a continuous wave that you can see with the lights on, so you can kind of get an idea. Next slide, please. Now, this is another phenomenon that I did not expect. I placed my cell phone about 4 inches above the arcs. and my cell phone worked perfectly, and it didn't short out into my cell phone. In fact, I was just standing over this, watching it, and I could feel no real electrical effects. Now, if you were to try this with a conventional Tesla coil, first thing that would happen is that your phone would at least stop operation. It would at least freeze up. And that's if you didn't fry it. Also, too, you would find that these little lightning bolts would probably want to come and touch you and let you know you're there. But for some reason, I can just stand over it completely. My phone's about 4 inches away, and yet I can enjoy the display and not be affected. And again, it has to do with something of the geometry of that sphere. It's so efficient that it's either absorbing all the radiant energy and putting it into the confined output, or it's doing something else that I haven't discovered yet. And I'll love to hear your opinions when we get to the end here. Next slide. This is, again, the same phenomenon, but as I tune it, you can see that they're getting bigger and bigger. At its biggest, I'm able to throw it arcs about 3 times the diameter of the sphere, which is pretty cool. Next slide, please. So again, let's see. Yep, so more tuning. So you're seeing it a little bit better, a little bit more output. We'll talk about tuning again in here in a little bit. I just don't get tired of these. Maybe you guys are, so maybe we'll rush through them. But these are just so fascinating to me. All right, next video or next clip, please. So they're just getting a little bit bigger as I tune. Next slide, please. Now, this coil is only 4 inches high. And I'll tell you what, this thing is incredibly powerful. It has 2,500 windings. It's set in epoxy like my other designs. And you can see that it just lights up this argon vacuum tube. Very cool. Next slide, please. Now, I'm putting the sphere literally right on that same coil. That same tube. And look, it has no effect. The output of the Death Star has no effect on that tube, while my little 4-inch cylinder was lighting up that tube. Now again, it has to do with something about the sphere is perfectly containing all of the energy and then putting it out efficiently. And so it's not exciting any other thing other than the arc discharge that you're seeing here. It's like an illusion here, but literally the output needle, that copper needle, is almost touching it, and yet it has no effect. Next slide. All right, so can we make this bigger or? Thank you. And so here's an infrared picture of the Death Star. You can see that everything is relatively cool, except for the 2 inductive chokes. And that's good. Those inductive chokes are rated at 15 amps. I'm putting in about 7. So they're expected to get warm. But left of those chokes are the MOSFETs. And you can't even see them in infrared. That's how cool they are. This is the temperature of the circuits that are powering those giant arcs that you're seeing. This is so fascinating. Next slide, please. Okay, so I've finally been able to solve the mystery of the ZVS high voltage oscillator. how can I then teach others how to build what I've built? So what I've done is I've created a 3-step process. If you follow these 3 steps, you can get your ZVS to power any geometry, any kind of coil configuration that you can imagine, and you will get high voltage arcs. That is how cool the ZVS is. So this really is step 1. Now you're going to need some equipment. This might be cost prohibitive for some. My equipment I buy very inexpensive on Amazon. I don't spend a lot of money. So for example, this oscilloscope's about $350. This signal generator's $100. And that power supply, 60 volts, 24 amps. It's a beast. Is the most expensive power supply I have. It's $260. These are all on Amazon, easy to find. But what you do is you connect them in a certain way to your secondary coil, as you can see on the right, and you're going to connect it with a resistor. And then what you're going to do is you're going to sweep with different frequencies until you have the minimum amplitude on your oscope. Once you get the minimal amplitude on your oscope after sweeping between about 10 kilohertz and 1 megahertz, that is your resonant frequency. I wrote it on the side of the blue coil here, and then I went to step 2. Next slide, please. Step 2 is, you can see there's my primary coil, coil 1. I hook it up to my LCR meter so I can get the inductance. So now I have the resonant frequency, and now I have the inductance. Now we go to step 3. Next slide, sorry. And so in the highlighted yellow, I put in the values, 201 kilohertz for the resonant frequency of the blue coil, 5.6 microhenries for the primary coil. And now this calculator gives me the answer. I need 57 nanofarads. And so what I'll do is I'll put 57 nanofarads, and now I have a powerful Tesla coil that's safe to put on your desk. You won't need hearing protection, and it won't be pumping out ozone, and yet you can perform all of your plasma experiments. So this is basically step 3. Next slide. Instead of buying every different kind of value capacitors, I basically solder them in different ways. And so then when I put them across my meter, I get different values. So this little cluster of capacitors, if I connect them in a certain way, I can get 214 nanofarads, 55 nanofarads, 73, 109, and 44. So this is a way to kind of get a variable capacitor without buying an expensive variable capacitor. Is just to, again, just connect them in certain configurations. Next slide. Once I find a value of a capacitor that resonates with my ZVS Tesla coil, what I'll do is to get more power, I'll configure more capacitors by soldering them together in series and in parallel. So that way they have the same value as a single capacitor, and yet you can push a lot more power through them. So what you're looking at here is the single capacitor on the right is the exact same value as the group of 6 capacitors on the left, and that's because they're connected in series and parallel. So this is very, very useful tip when you're trying to get resonant frequency on your ZVS Tesla coil. Next slide. What was really cool is I needed 331 nanofarads for the sphere, and all of my capacitor configurations didn't have that value. So I just flipped over one of my groups of soldered capacitors, and I just started connecting my capacitor meter, and lo and behold, I found in this connection display, I have the exact 331 nanofarads that I needed. So this is just a really cool trick. So you don't have to buy all kinds of capacitors. It's just solder them together and check out all the cool values you can get out of them, and then use the values that you need. Next slide. This is what is called a capacitor calculator. So if you don't want to solder them all together to figure out what their values are, just throw them in these calculators and connect them in series and parallel, and then you'll be able to figure out how you can get the capacitive value that you need. And so again, you don't have to buy new capacitors. You can just connect them in creative ways and get the values that you need. Next slide. These are my two favorite capacitors. So if you want to go back and watch the video, there's a lot of reasons why I use these capacitors. They're very cheap, but they're very powerful. And that's a very difficult combination to find. If you're going to find awesome capacitors, usually going to pay a premium. You'll pay $3, $5, $10 a capacitor. I paid 80 cents for the capacitor on the right and a little over $1 on the one on the left. And so people who build these things know how cheap that is for the quality. Next slide. Now, this is one of my moving forward inventions. What you're seeing here is a spool of rectangular wire. And so I'm going to take the same groove design, but instead of putting in the normal round magnetic wire, I'm going to take a very thin but very wide rectangular wire in order to get about 5 to 6 times the current into the same geometry. What you've seen so far is from 3 to about 9 amps at being the highest. This little coil is going to be handling something like 50 amps. And so what's going to come out of this, I don't even know, but I can't wait. Next slide. So how I cheat the system is it's 32 gauge in width, but it's like 12 gauge in oh my goodness, I got it reversed. It's 32 gauge in thickness, and then it's about 12 gauge in width. So what you're seeing here is about 55 turns of 32 gauge wire, even though it can manage 5 times the current. So I'll be putting out a video on that soon. Next slide. I'm also working on a new geometry. So I'm going to go from the sphere to the toroid. Now, the sphere seems to not allow electric charge outside its boundaries. So I'm kind of wondering if the toroid won't let magnetic lines out of its geometry. Either way, this thing is going to be really cool when I can get it working, and I'll definitely have a video for that as well. And again, I put the Bic lighter in there to just get scale. The stuff I work on is not very big, even though it looks big. The only thing big are the plasma arc discharges, which is why I love these designs. Next slide, please. And there it is put together, and it's going to be harder to wind than the sphere. So next slide. If you recall, this is the 5,000 winding coil that I had submerged in epoxy resin and then vacuum chambered the bubbles. The inductance of this coil is so high that it doesn't even show up on my LCR meter. I think my LCR meter can go up to Henry's and also to the Q factor on this coil. I mean, it's I've seen my meter go up as high as 1500 Q quality factor. This thing is off the charts. So this thing's going to be really interesting to see. It's not bigger than the other coils, it's 6 inches, but wow, the inductance on this thing is off the charts, which I believe is going to relate to powerful discharges. Next slide. So when I'm winding the primary coil, I like to try different geometries as well. Nathan was keen in seeing this in one of my videos. So what you're seeing here is 12 gauge magnet wire, and I wound it into sort of a spring-like configuration. And so this here now fits in a 3-inch diameter primary setup, but yet it's about 25 feet of 12 gauge wire. And so what I was trying to do here is to just maximize the inductance in the primary without it increasing the space. Unfortunately, in testing, using this as the primary is not a good idea. The back EMF, the flyback effects, it just eddy currents, it just heats this thing up. This thing gets hot to touch. And in all of the Tesla coils I've ever built, I've never had a primary even get warm. This primary gets too hot to touch. So it was a concept, and it just gives you an idea of some of the concepts I try. We'd be here all day if I showed you all my configurations, but this is one of my creative ones. Next slide. So this is another thing I'm going to be building. It has 8 MOSFETs instead of 2. It has those giant cooling fans because it's actually going to need it, because for that rectangular wire, it's going to need some serious amperage. And so this will handle the 50 amps that I want to put into that, that new coil. Next slide. This was my second iteration of that grooved coil design. And I kept having discharges from the side breaking through the epoxy. And so I decided, you know what, I'm just going to put an inch thick wall of epoxy around this coil, and I'm going to stop it from discharging from the side. And you know what happened? It still discharged from the side. I still had plasma breaking right through a solid inch of epoxy. So just to give you an idea of how powerful these sparks are for these for the size of these coils. Next slide. This is just now a little bit of miscellaneous, and we're almost done. I appreciate your all patience. I go to thrift stores primarily for all of my storage bins, and I buy everything in clear acrylic. And then I store everything where you can see through them. And this helps a lot because I'm a very disorganized person. But also, too, I'll grab one of these and use them as the primary coil for my Tesla coils. So there's a lot you can do when you go into the kitchen section of a thrift store. Next slide. This is what so you see 29 volts, and it goes down to 2 volts. Now 24 amps. Now it goes to 29 volts, and then it goes to 2 volts and 24 amps. Okay, I think it's going to do it one more time. 29 volts down to 2.5 volts, 24 amps, and then back to 29 volts. The reason why I want to show you this is because this means your ZVS is not working. You need to see the 29 volts stay. Okay. If you see the voltage drop like this, it's one of 2 issues. One, it's not oscillating, and you're just going to fry your board. Okay. So you want to stop it when it goes down in voltage. So that's what it means. It's not oscillating. Or 2, you blew a MOSFET. Then it's just going to read 2 volts because a MOSFET acts like a short. It's like a 2 ohm resistor. And so I just thought this was cool because I didn't know this when I was setting up the ZVS, and this really troubleshoots most of your problems. When you see this drop down, it's a MOSFET, maybe a diode, or it's not oscillating. Next slide. I don't think that's my slide. Oh, we're done. I think this is Nathan's. Well, thank you for your patience, everybody. I'm open to take questions at this time.
And bring everybody in. Go ahead, guys. That I can't even put words to that, man. That was so
Yeah,
awesome.
that was.
I think we should give him a round of applause. That was awesome.
Yeah, natural presenter.
Thank you, guys. It means a lot.
That was great.
You know, it takes
Appreciate
a lot of courage to get up here and present like that, and you just did it like without hesitation. I love it. We got a couple of questions from chat. Yeah. We got a question here from Brendan who wants to know, is there a ZVS driver and a plasma TV that he's looking for one?
So when people think ZVS, they tend to think that it's going to have that TV flyback setup. And then once the ZVS powers the ZVS flyback transformer that are in TV sets, then that output's going to go to some spark gap Tesla coil. The ZVSs that I'm using, they don't use that flyback transformer that are in TV sets. And so because of that, I just skip that step and just go straight to the Tesla coil.
Okay, nice. We got another question from Tammy who wants to know, how thick is the epoxy? I think she was referring to your Death Star coil or the coil before that in your presentation.
Good question. So rule of thumb, I try to keep 1 millimeter of thickness, except for that red coil. I just was tired of plasma breaking out the sides, and that's when I put the inch thick of epoxy, and it didn't help. But generally, it's 1 millimeter thick.
1 millimeter. We got one more quick question from Sue Spectacular, who asked, what are your thoughts on harnessing this energy in a manageable, practical way? She's a mechanical engineer and loves designing practical, usable material-based items.
Yeah, that's a really good question. I think once you get a lot of plasma on your desk and you start testing it in different ways, I don't think we've really bottomed out on our knowledge of plasma. I just don't think we have. So, so practical purposes with plasma, great question. See, I just set the goal for my Tesla coils here to reach 1 million volts. I haven't really thought past that yet. I do know. Thumbs up. Yeah, we'll be doing another video if you guys are interested when I hit 1 million.
Oh, heck yeah.
I might be wearing red underwear, but we'll do it.
I don't know if you read my comments on the last show, but I'm looking for 1.25 for a specific project. Me and you should talk.
Sure. Be glad to.
That'd be awesome.
Sounds good. Oh, egg-shaped coil. Not yet. It does sound cool. I have a whole list of geometries that I want to build. So good idea. Thank you.
Yeah, I'm looking to build a sphere with a hourglass shape in the middle, and the sphere covers everything, and it's all coil. I have the design. I attempted it once, but I need a 3D printer to build the scaffolding properly in order to have this work. Because it's a tough wind the way I do it. It's not.
Yeah, you definitely gotta have some kind of frame.
Yeah.
Sounds very cool. Sounds interesting. Yeah, I'd love to collaborate with you. I'm really impressed with your stuff. So that would be wonderful.
And likewise, your idea for the way you did Tesla coils, outside the box, amazing. Like my mind was blown. That's how we have to do these things. We have to think completely differently than what was done. Let's add some crazy stuff to it. And as Nathan always says, try it, find it. Right?
Right.
So,
it's so funny.
I have to quickly jump into in regards to the egg-shaped coils, the Keshi KFSSI Foundation, their anti-gravity coil or propulsion coil is a giant egg-shaped coil design or geometry with their star setup, which is like 3 or 6 of the monoatomic Ormus things spinning in the middle. But then the egg coil is actually several like triple solenoid coils, but of egg 3 coils within coils within coils, all egg shapes going around in a bigger egg shape shell around the spinning monoatomic. So
wow,
fascinating.
I'd love to see that.
And that's the one video that like I saw like 5 or 6 years ago. Some member was like reproduced it, I think, in like Vancouver, the west coast of Canada, and he lit it up on one of the live Zooms, and it actually like produced a glowing plasma field from what we saw like on the Zoom, and then it's like I have never been able to find that video since.
Oh no. I've been there.
I got an interview upcoming with Mehran Keshi, so I'm going to ask him about that and see if they can line it up for that.
Awesome. Thanks for sharing. Ben, do you mind reading some more questions?
Yeah. So we got one question here. Is there any configuration of a ZVS driver that can produce current impulses, like half wave, single polarity direction, or is it only able to work usefully with resonance in both polarities?
Yeah, that's a good question. So I know the flyback transformer out of TVs has the high voltage diodes on the output, so it definitely produces sort of like a quarter or half wave polarity. I haven't tried it yet. I know that SciTube HD tried throwing a high voltage diode right on top of his Tesla coil breakout, and then he does readings. So I don't know if that might answer your question. Again, it's SciTube, like science, SCI, tube, HD. And if oh, thank you. Oh, that's my wife. Thank you, sweetie.
Support from home, right? That's the best part. Like,
yeah,
that's awesome.
Thank you.
He's a great guy, and he has amazing tech. He's going to be able to revolutionize Tesla coils, and I say that with full confidence.
Absolutely.
Sorry to interrupt. Go ahead.
No, not at all. I'm glad you chimed in. Yeah, SciTube HD collaborated with Archangel. Now, Archangel deserves a lot of credit as well. In fact, when I saw them, they were my inspiration to go to what you guys have seen now today.
Nice. I follow them as well.
Awesome.
That's really crazy.
Ben asked me today, do I need to prep for anything or look up anything? I said it won't help.
Yeah.
Yeah.
It's crazy though.
Out of the box.
We're all kind of like onto something in our respective like areas, and coming together on this show is amazing. Having Shawn on here, it's really an honor.
Bring together the best minds in the world of all you garage geniuses and builders, and then it's like you're all sharing, like, and it's like, oh yeah, I've seen that effect. Oh yeah, I know that effect, right? And then it's like everybody's factor of understanding is just growing exponentially. It's a wonderful thing.
Yes. Hey, and I just want to say I love your background. All your
it's nice.
Art. It's so
Nathan
cool.
picked that. Yeah.
Hey,
he did a great job with this.
Oh, thank you. By the way, I think I know why your coil wasn't attacking that cylinder.
Okay.
If you noticed, you had swirls in it.
Mm-hmm.
Okay. And it looks like you're sucking in the energy, not pushing it out. So it's swirling in, it looked like. I don't know if you noticed that.
Oh, I have to look at it again. Wow.
Yeah, I'll put it up in here a little bit when you're done with some questions. We'll take a look at it as a group and see if it's doing that or something else.
Awesome. I see a question. When you're epoxying, are you also doing in vacuum? Might fix the arcing issue. So how I vacuum the epoxy is I have a Verver generic vacuum generator or vacuum pump, and it looks like a 5-gallon tin pot for canning, but it has a thick clear lid. And so what I do is when I mix the epoxy, I then take that container that I mixed, put it in there, and then I crank the vacuum. Watch all the bubbles come out. I'll free it up, release the vacuum, then vacuum it again, and then release it, vacuum it again. I'll do that 3 times. And then I'll pull in my form for my Tesla coil, and then I'll pour that into the form. And then I do 3 more vacuum rounds with that. So there's really nothing left by the time I'm letting the epoxy set. Does that make
Right. You
sense?
said there's no air bubbles or anything.
Yes, if you look deep inside it, it's just amazing how clear. Yeah, there's my setup. There's the pot, and there's the colorful form where the sphere is inside.
That's cool.
And yeah, it's vacuum pumping is fun. I don't know why.
So I got a question. How long does it take from the beginning of the process of vacuuming to the time you allow it to set? Do you know?
Yeah, good question. Yeah. The two-part epoxy that I use basically hardens in about an hour or two. It gets really hot, almost hot to touch.
Oh yeah.
And 24 hours, it's hard, but you could probably bend it a little jiggly. So really I think it takes 2 weeks to fully cure.
Within those 24 hours, the next coil we build, I got a little suggestion for you.
Okay.
Once it's at the point where it's a little jiggly, start pulsing it. You might actually create yourself an electret.
Interesting. Oh, that's a really good idea.
Yeah, it'd be a really neat experiment. That's what I want to do on my next system. But again, I got a lot going on, so when I get to it. But please, I hope you do it first, because then I may not have to, or I may just take instruction from you by far.
Sure.
Yeah,
Dang.
so sorry to interrupt though, but yeah, that's awesome.
Thank you.
Is there any other questions out there?
We're open for questions, everybody.
Sorry, I just emailed the link to Charlie and Jared Yates and a couple more to see if they want to hop in and ask any other questions on this too, because I know we're all working for the same goal here with the Gravify and understanding what a Tesla coil truly is, right? It's remarkable, Shawn, what you've discovered and built here, and you're demonstrating with it.
I appreciate
I
that.
have a question.
Sure.
So you said you work on intuition, and like a lot of us here, do you have any sort of inspiration for your design for the Death Star coil, or what you're doing with these Tesla coils, or did you have a dream or a vision? Because I know a lot of us here have had dreams or visions that have guided us in our work.
Yeah, that's a really good idea. I guess I say that I try to approach it intuitively because I don't want to get bogged down with math, or I don't want to get bogged down with terminology. So, you build 100 Tesla coils like I have that don't work. And then all of a sudden you get into this groove where you know what you need to do, and you can kind of put away the calculator. What inspired me to make these geometric condensed coils was more of I just thought Tesla coils were ugly and loud, and I didn't want them around me. I just thought, but I want to be in my lab and play with them, and they're just, oh my goodness, you gotta put them in your garage or out in your yard, and you need to wear earring protection. And so that was really what it was, more of practicality that necessitated this. And a little fun fact, so Tesla coil, there's a Tesla Coil Association. I don't know if you've heard of it, or foundation. And it's basically a group of the top coilers in the country. They have these 15-foot, 20-foot Tesla coils. They travel and do shows. So
I think I've seen some of those videos.
Yeah, I believe Jeremiah Pop may have been part of that in the beginning. I'm not sure, but I know he built some really crazy coils. So
I also suspect they might be a part of the Beakerhead Science Festival in Calgary that is every year, where they have big Tesla coils set up, and might be part of that with what you're describing.
Yeah, interesting. Yes. And these guys are the pros. You go to their websites. I mean, they tell you everything about a Tesla coil. So I reached out to one of them and I basically inquired of my designs that you guys saw here, just some of my designs. And the answer was, don't do it. They'll never work. There's a reason why we do it the way we do it. And I thought, so that's another reason why I wanted to build these, was just sort of necessity. And also I kind of felt like there's a challenge there, a guy who knows way more than me. And
can I say something on that? If I had a nickel for every time somebody said that to me, I'd be a millionaire today. I'm telling you. I don't listen to people's negative. To me, it's like when they say, don't do this, it won't work. Well, I'm definitely going to do it because I want to see how it doesn't work.
Exactly.
Right? So that's the way to go, man. Awesome.
So I got to point out, Jack Serfati, he stated that he himself wants to be described as an intuitive genius, right? That it's
Jack Serfati is a schmuck. I'm just kidding.
Right? I almost made his schmuck list the last time I was on with him, but I held it together. And
I like Jack, but his ego's bigger than the screen. So
everybody's building Tesla coils, and Shawn's building a Tesla coil 2.0 over here. He's officially upgraded the Tesla coil.
I'm sorry, Ben. I disagree. He's building like
I got someone
a brand new system. You think it's beyond a Tesla 2.0?
Yeah, appreciate you guys.
But you get the idea, though. Everybody's building the same old thing, and he's going to another level. So
yeah, thank you.
That's the analogy here that's important.
I just wanted to say, Jack, if you're listening, you're great. I'm just messing with you. Now you're on the schmuck list, okay? I'm just kidding. Go ahead.
Oh, just real quick, my wife chimed in and said I get inspiration when we talk, and yeah,
we love you, Jack.
My biggest inspiration.
That's awesome, brother. That's
Thanks.
Awesome.
32 years of marriage.
Oh, nice.
Good for you. That's great.
Thanks.
So let's take a look at this real quick. Here it is. We're just going to zoom it in. You see the swirls right here?
Yes.
And they look like they go down. Swirl again and go down. I might be crazy, but it looks like it's pulling it in versus pushing it out. And it could very well just be breaking out of there like this.
Wow. Good catch.
But there's something going on here in the way it's, you know what I mean, going down.
Yeah.
You can see it, boom, and then it goes. It almost looks like it's like a drain tube.
Right. They do. I never noticed that. And what are you guys' thoughts on my camera, my phone being 4 inches away from these 12-inch high voltage arcs?
That's insane.
You had your amps
Maybe
very well
something
controlled.
to do with cold electricity. Huh? What'd you say, Mike?
Well, it can't. The thing is, if it's pulling it in from everywhere else, then you shouldn't have anything. That would be the coolest thing if you could verify that.
Wow.
But,
yeah.
it might be some kind of cold electricity. I don't know. Cold electricity.
No. It's pulling in from the area around it, right? So if the Tesla coil is pulling in instead of pushing out like we all think it is, it would be a whole big discovery to find out if it's swirling in, and then we just didn't have it high enough to find it.
Here's a thought for you. Were you holding your phone when you recorded that 4 inches above?
Yes.
So if it's pulling energy, just a thought, maybe it's pulling energy from the ground through your phone, and that's why your phone is still operating.
Oh, you're grounded?
That's interesting.
Well, just standing on the ground, right?
Well, so I have a very thick plastic coating under my lab, so I'm never grounded. And I also wear these thick rubber shoes, but that's an interesting theory. My theory was, and let me know if what you guys think. In order to test or measure high voltage, it gets real difficult because let's say you have two probes 1 inch apart. When the high voltage breaks the barrier to one probe to the other, it establishes then a connection of plasma, and then the resistance ends up being very low. And so in my reading, the solution to measuring it accurately is to have two spheres, because a sphere will equally distribute the charge on both spheres. So when it actually does break the arc, it's going to be a lot harder. It's going to be more representatory of the actual voltage. And so what my thinking was with the sphere is that it so evenly distributes the charge that it's not allowing that charge outside or past the sphere. And so therefore, you're not getting that field that lights up neon bulbs and other fluorescent lights. And that's my theory.
Charge compression.
Yeah, like Nathan said, it's going inward, not pushing outward.
That's amazing. Good catch.
That's
Yeah.
wow.
Yeah, that helped me understand it actually. What he said. Because honestly, this is a little above me until he said that. I'm like, oh, okay.
Nice.
Yeah, that, you know what? You could use that for the. Oh, we have to do a Zoom behind the scenes, and I bet you we could come up with something and build something that's never been seen before, because that could be literally the heart of a system for a whole ship.
Sounds awesome. I would love to collaborate on that.
That would be amazing.
Yeah, at your service, sir. I'd love to help.
We got some more questions here,
Great.
if you don't mind.
Yep, I'll back out of here.
Sure.
No, it's all good. Question, guys: has anyone you guys know made a particle accelerator any size?
I've only heard of Bob Lazar supposedly making one in his backyard to run his solar-powered hydrogen car or something. But
I
that's
think
a Bob
microwave
Lazar
cyclotrons
story.
do the same thing.
Yeah, Russ Grease built the EPG, and that's essentially a low-level particle accelerator. So maybe I haven't though. I mean, it's great.
Here's another question. Oh, sorry. Here's another question. How do you intend to wind the toroid? Is it a spiral or circular wind?
I think it has to be a spiral because it has to move through the entire toroid. So the circular idea is interesting if you created 100 rings instead of 100 spiral windings, but then you would have to figure out how to connect those 100 rings in that toroid shape. I have a theory here I'd love to run by you guys. If the sphere holds charge equally, and Mike could probably help answer this because he knows transformers. A toroid transformer doesn't allow the magnetic lines to escape. It efficiently contains all the magnetic lines. What if my toroid does the opposite of the sphere? The sphere doesn't allow electric charge leave, whereas the toroid won't let out magnetic lines of force.
Like the opposite effect.
Yeah, the sphere would be the opposite of the toroid because
it makes sense.
Step back a little bit.
Sense.
You said something about this. Is the sphere also iron?
So just the toroid. If I'm going to wrap the toroid like you would wrap a toroid transformer, but yet I'm going to use that toroid as a Tesla coil. So
to give a little context,
transformer will
trying to give
contain
an
the
understanding
field.
of what you're saying, Shawn. Like, are you referring to kind of how like Bob Greenier in his donut coil, or that the inner wire is like iron or ferrite, and then it's copper on the outside, sort of field effects? Or
I see. Yeah, that's a good question. So as soon as you add, let's say, any kind of core to a Tesla coil secondary, you're reducing its frequency range to a maximum of 25 kilohertz. And after that, what happens is that metal core, whether it be iron or ferrite, whatever you want to put in as a core, it begins to saturate. And then you start losing power significantly. And I haven't seen a 25 kilohertz Tesla coil, but it would be interesting because that is definitely low frequency. But these are air core, and I'm using the 3D print as just a guide to guide the wire.
Air core is the best. You can get the highest frequencies, and anomalies seem to come out of them a little bit differently than what Bob Grenier's, I can't remember what he called it, toroid coil.
No, the donut. What? No, is it the donut?
Donut coil? I can't remember.
Right.
It does some crazy
I don't
stuff too,
remember.
but it wouldn't reach the high frequencies that that Shawn's talking about, or that we're trying to intend to get to. So I get that. That was an awesome answer to that question, Shawn. I'll shut up now.
No, it's great. No, I love the input. Good
Right. So the
question.
ferrite core doesn't work because as it heats, it loses the magnetic field. Correct. That's what is disrupting the power, as you're saying.
I mean, it will heat, but it'll slow down the frequency response of the magnetic field as it builds up and contracts. It'll begin to work against it, and it'll definitely get hot.
What about something like a bismuth aluminum agglomeration?
Whoa, hold on. You guys know about the Thane-Hines transformer? That thing redirects the extra flux that creates that heat.
Bagel coil, that's what it is. My bad. Bagel, not donut. Not donut. Bagel coil.
Smear me.
The Thane Hines.
Gerald knows about the Thane-Hines, right?
Yeah, it's amazing actually. I took my 1-inch coil and I made like a closed in H bar of ferrite cores, and I had 3 pickup coils, and I just pulsed my primary on this little vortex 1-inch coil I had, and I was lighting a bunch of LEDs. I think I was getting like 64 volts on one coil, and
Wow.
yeah, you just
Yeah, that's
redirect
cool.
your magnetics in order to use your electrostatics in that system. From my understanding.
The picture of the Thane-Hines transformer is basically 2 square iron cores. One is thicker than the other, and they're put together at one of each of their arms. And the thicker side takes the excess flux, and you're supposed to draw it off with a coil so it don't build.
How do you spell that?
Thane-Hines? I don't know exactly. I keep spelling it wrong too.
I'll just get close.
It's there. I mean, it's on the YouTube everywhere. I think
Sounds
it is.
cool. Sounds cool. Thank you.
Thane, Thane, or Thane?
I don't know.
Yeah.
I'll Google it.
The bitorial. Is it the bitorial? No, the transformer bitorial? No. Sorry,
Bipolar.
Thane-Hines, just search Thane-Hines transformer. Maybe that's what he's known for, is that
It's
transformer.
THANE, and then it's HEIN bitoroid transformer.
Hein.
I'm just
There you
writing it down. Thank you so much. I'll have to look at it. Very cool.
I've never messed with that, but I looked at it and I really like the idea.
Yeah.
Let's see what Gerald's got going on over here.
He's drawing the Thane-Hines transformer. Right. This is an awesome concept for many avenues of experiments for redirecting flux in the iron. But like Gerald said, without the iron flux, you could speed up your frequency because the iron flux is kind of, slowing down stuff. If you can't get rid of the flux fast enough, it will. It will build up and slow down your frequency and, kind of push back.
Yeah, I was building my own flyback transformers, and I love the way you put a ferrite core in there, and it increases the inductance 10 times. It increases the efficiency, and it's wonderful. It's almost like a magnetic lines of flux amplifier. But then once I started bringing it up into frequencies for the Tesla coil, it was a disaster. It just stopped working.
Also in the private chat, I put
there's ways of winding the solenoid back and forth. I wish I knew the name or the video, but I watched it in one of the Periscope like 50s or 60s videos that literally showed them like winding the copper around the iron like a different manner, like over top of itself or back around a couple times. There's like a couple different ways, but it was like then they explained each way of how it like circumvented those issues, sort of thing. If that makes
sense. That's a really cool idea.
Shawn is your name? Shawn? Was it Shawn?
Yes.
There's a guy named Holcomb Energy. Holcomb, I forgot his first name, but
Holcomb Energies, yeah.
Holcomb Energy Systems. He builds these like intricate iron core systems to do what you're saying, like to amplify the flux using the iron.
Wow, fascinating.
So that's kind of what this is. This is the Thane replica I did. I put my vortex coil around 2 square ferrite cores. I had a wrap of 120 here, 120 here, 120 here. This one was just a capacitor to hold the flux. I didn't draw this right, but these are a series of LEDs and they lit up.
Okay.
And this core here, I didn't even put it on the board, but it had a series of LEDs that lit up as well. And my secondary was picking up voltage at 64 volts.
Wow, that's
And
amazing.
that was, yeah, and that was all from pulsing like 7 volts onto the primary.
Wow, the power of resonance. Wow.
So Thane system redirects the magnetic energy inside the circuit itself and allows you to use the electrostatic and separate the two, so to speak.
Wow.
You know, I was thinking, technically speaking, the iron is a flux capacitor.
Yeah.
Yeah. Everything has capacitance. Yeah, I can see that. Very cool.
That's
well, I have a
awesome.
lot to look up.
So, Shawn, I have something for you. This right here is your identification of the AC that's going in. Can you explain this?
Sure. So these are what I connect to the Variac, the red Variac that we all know and love. And what happens is, of course, it's AC output, so there's no red and black, but I just use red and black to make sure that I was doing the things that matched my model. So what you're seeing here is that when an AC sine wave comes in, it's going to clip the negative part of the sine wave. So all you're going to get is the positive. And so what happens is that when the red lead and the black lead are coming in to build the sine wave, those diodes clip the negative hump. So then only the positive hump comes through and meets at the Tesla coil. And that's why, so have you guys ever heard of a Tesla coil interrupter where you'll see the Tesla coil and it will stop and then blink on, blink off, blink on, blink off. It makes a popping sound. Pop, 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 pop. It's called an interrupter.
I've never heard of that. Yeah,
Me neither. Never seen it either. That's awesome.
Oh, wow. I'll do a little video on that. I don't know if you guys knew, just real quick side point. I have no YouTube channel, and I had no idea that Nathan was going to make that montage and throw me in the deep end of the pool. But I just want to let you guys know that I want to say thank you, Nathan. I rushed to at least change, so it's not a generic channel, and I'll be making videos of all of my inventions and how to build them. So yes, what you're just seeing here is I think it's called a quarter wave rectifier, but I'd have to Google it.
Nice.
That's the purpose of, and the reason why I have the diodes in parallel like that is because you can push more current through them. That's the only reason. So if you add things in parallel, it allows more current. If you put things in series, you can handle higher voltage.
So I'm not exactly sure what I'm seeing, although I know. Oh, okay. I'm just blind. I apologize.
What drove me nuts when I first looked at this is right here. These two diodes look backward. And I kept asking Shawn, are you sure they go that way? Because I was completely lost. I'm like, these look like they're going towards
It's a rectifier.
Stop the energy. Yeah.
Right.
Didn't understand it right.
It's a half bridge.
They're both going the same way, right?
Yeah.
No, opposite way. Because you got to rectify the AC going one way and not coming back the other. He's trying to make.
So they're doing this.
So it gets you positive humps instead of negative humps.
Right.
That does.
So a sawtooth wave, right?
It's not a sawtooth. It's a pure positive sine wave hump. And I just wanted to mention that what the Tesla coil is in effect doing is literally turning on quickly and turning off quickly at 60 hertz. And so it gives bursts, creating those long lightning bolt shapes. because it has interruptions and bursts, interruptions and bursts. When I do pure DC, that's when you get that big white fluffy ball of pure power.
The way that
Well,
I
if it's, I'm
the way
sorry, if it's positive instead of a negative, wouldn't that be phase shifting it?
AC has no polarity. It flips polarity each cycle.
yeah.
Correct. So I'm filtering out the negative polarity every time it flips.
There you go.
Is the-
You guys are racking your brain now, huh?
Hey guys, hold on.
These
I
are great
just need to give a
questions.
shout out right now. Okay, Bog Irish. Everybody say hello to Ian.
Hey,
Ian!
Hi, Ian.
Hey,
Ian.
Ian came on the show, man. Totally awesome. Love that he's here.
Yeah, he's got some great geometries. He's definitely up there. I would say he's going to be doing something unique in the near future.
Yeah.
If he can get any more than unique that he's already done. The collaboration that's coming together here, I'm going to start taking it back 6 months building a ship. I was wrong. I'm going into 5 months or 4. We just need the resources. This is crazy cool. I love it.
I told you Shawn was good.
Thank you. Appreciate
I
it.
put on my little hat with my little propeller when he comes on and shows me something new. I spin it around and let him talk.
Yeah, you put a channel out there, Shawn. We'll fill it. We'll get a bunch of subscribers for you.
Appreciate that.
The way you were explaining it before with the energy, how it comes in and it kind of fills, and I usually explain it when I'm pulsing. When you turn a light on, like you flip the switch, and the power fills the line and it turns the light bulb on. When you flick that switch off, all the power that's in that line races back faster than it did go in. I'm talking DC here.
Right.
At the same time, when we pulse our stuff and our different transformers, it kind of comes out the same way. So that was just my point.
That's a good point. Good point. Thanks for sharing. Ben, you mentioned a phase shift. Phase shifts occur with between the capacitor and the inductor. So the inductor is going to slow down current, whereas the capacitor is going to slow down voltage. And so if you compare the current and the voltage between the inductor and the capacitor, they're out of phase. You'll see that they're out of phase from each other. And so I don't know if that answers your question. And so I'll go a little bit further. So when the capacitor and the inductor have a AC signal and they begin to oscillate, a DC signal to come in and oscillate, when you achieve their resonant frequency is when they are completely undampened to release all the power that they can. And that's really what's occurring in all the Tesla coils, if that makes sense.
No, it does. That's actually, you went beyond answering the question and you clarified it fully. Thank you.
Yeah.
Sure.
Beyond sense. That's perfect. Perfect explanation.
Yeah. Thank you. I'll tell you what, guys, I watch you guys all the time, and I just thought, wow, to be around so many smart people. I told my wife it'll be good for me to be the dumbest guy in the room because they'll up my game.
Oh, don't even go there. You ain't getting out of this one, buddy.
Yeah.
You know how smart you are.
You're just a different aspect of the game. Like I was saying before, I like Mike does. He gets excited about how he's explaining things to me, and I get excited explaining things to him. We need different opinions and different angles to come at this, and by doing that, get this done quick.
Yeah,
so I like your style. It's awesome.
Thank you so much. So when I was going through some of the phenomenon, when the sphere was out of tune, I could light up a neon bulb about 3 feet away. I didn't share that in the presentation. It was a lot of content, but I didn't share that when it's not in tune, it tends to really radiate at distances for its size further than you would expect, because it's only a 4-inch ball. But yet 3 feet away is when I was seeing my little fluorescent lamp light up. But as I brought it into tune, I couldn't get anything to light up near the coil. So I was going to run that by you guys. What are your thoughts on that?
Yeah, that's weird. So you tuned the coil and the lights went out.
You know how you do the wireless, hold the light bulb next to the Tesla coil and it lights up in your hand?
I've never replicated a coil, but I've seen many people do that. Yeah.
Yeah, exactly. It did it further than your average coil when the coil was out of tune. And when I say out of tune, it was a frequency that was not close to its resonant frequency. And by the way, I haven't been able to tune my stuff within more than a 1,000 hertz range. So
there's
I still
a lot
have
of harmonics
1 kilohertz.
to the resonant frequency.
Yeah, so I have a whole 1 kilohertz to still tune it, but there are a lot of variables in that. So I have to shorten all my leads, get everything as close as possible. I need really thick copper, so that way I don't have any antennas, no sharp edges. I can then get in that perfect tune. But out of tune and it pumps out radiant energy. In tune, it's like a different Tesla coil.
So that's very interesting. I kind of wonder if when you were doing your resonant tuning and you were lighting neon, did you go further than 3 feet? Like say even 13, 12 and a half, 13 feet?
Oh, no, not that far. It was about 2 to 3 feet when normally my small coils, if they're about a foot, 18 inches. Because they're so small, you see people with a 2-foot Tesla coil, you're going to light up fluorescent bulbs on the other side of the room. But no, it surprised me that little sphere lit up things with radiant energy. But when I put it in tune, it was almost like a negative spot of radiant energy.
I just kind of wonder if you were pushing that sphere of energy a lot further out than you thought, and you created a null zone.
You could have made it more of a receiver, less of a transmitter.
Oh, that's an interesting idea. Thank you. I'm going to try that. See if there are null points.
Definitely. That's something that if you find, you're right over the target. You're getting very close to what we've seen in some of the systems that we're operating now.
Oh, thank you. That's a really good idea. I'll test that.
Awesome. Hey, Tim.
Hey, guys.
Hey, Tim.
I got the invite. Thank you for having me on.
Hi, Tim.
Absolutely.
Hey.
Nice to meet you. You're kind of a legend.
Oh, thank you, Shawn. I'm not a legend. I'm beat up. Especially
It's good to have you here, Tim.
Aren't we all?
Yeah. I'm gonna get Gerald to come at the APEC conference. I'll probably pull OldMan Builds back in at some point too. And I was thinking about getting Ben to come on at some point as well. But
awesome.
Yeah. So
Nice.
Jared, you guys know Jared Yates, right? So I was in Reno with him last week. That was our secret mission. And so we were helping the family of Dr. Friedwart Winterberg review and archive like a lifetime's worth of fusion materials. And this guy was like, he was a heavyweight, right? I mean, he worked Werner von Braun, Carl Sagan. His doctoral advisor was Werner Heisenberg. I mean, he was he was best friends with Edward Teller, who invented the H-bomb. This guy was as big as it gets. And we got to go through all of his files, all of his documentation. And actually, that was the problem. He had 35, those big file boxes, 35 file boxes of data.
Oh, wow.
And then he had over 100 3-ring binders with every letter he'd ever written or received going back to 1957. And so it's like, okay, we had a week to go through that. So we got maybe 5% of it. And there was a lot about fusion, and he was also really into UFOs.
Awesome.
And so we learned a lot, but in a weird way, it's like we don't even know what we've learned yet. I guess this was.
Were you not wearing camera glasses while you were looking through that? I'm kidding, Tim.
Like I was just pulling stuff out and handing it to Jared, and I'm like, dude, scan this, right? And the thing is, like Jared, like this was I'm gonna blame this entirely on Jared, right? Like I'm the victim here. Jared like absolutely loves this scientist. He's like, this guy is it. You have to come with me, you have to help me. And so I'm like there and I'm just like, what the heck? Or I'm just like, okay, here, scan this. And so Jared is actually going through and like if you guys touch base with him, he's already finding bits and pieces, and a lot of that just kind of escapes me. Like I know a fair amount about that area, about that fusion research, but like he has studied this, and so he's definitely the expert.
I did email Jared Yates the link to this right now, so hopefully he gets it and comes. Thank you, Tim, for joining us.
Yeah, well, maybe he'll come on. I don't know if he's, but. One thing I would say is, I mean, just for what it's worth, right? Like some of the stuff that I noticed, like, okay, so nothing in his files was classified. There was stuff that was declassified, right? But like nothing in all of these files was classified. And so what we think happened there was Winterberg, he changed from a couple of companies. He was at one called Desert Research Institute. He went over to University of Nevada. I think that when he changed companies, him or somebody else went through all those files and removed the classified stuff. That being said, there's a lot of stuff. He had like notes and sketches and math and stuff like that never would have been classified. It was just stuff that he did. And so we still found a ton of material, unpublished papers and stuff like that. And that's the important part, trying to preserve this legacy. So we did not find any smoking gun stuff on UFOs. Not that I could see. I didn't see anything like that, unfortunately. And Jared really thought this guy might have been involved with designing the TR-3B. And in a weird way, a lot of the stuff that he designed could have been used by that, but if it wasn't by him. Maybe it was.
Wow, that sounds about what you would find, though. All the archives of what it probably did go into the TR-3B. It's like if it does exist in Israel, is like locked away and like
it could be.
Nobody was allowed to sneak out any of them napkins on the way out.
It could be. So the other thing was Winterberg told his daughter, and we confirmed this. We talked about it with her at length. He told his daughter. So Reno is, I guess, northern Nevada. The Nevada test range, right, is farther south. He drove down to the test site. And he told his daughter he was going to Area 51 many times. Now, he may have been going there. He may have been going to another place called Area 11, which is kind of across the state. The Area 11 is where they do all the fusion research. But he told her, no question about this. He said, hey, Astrid, I'm going down to Area 51. Wouldn't you love to go with me? And he said that multiple times. So take that for what it's worth. I mean, this, so there was that. And the other part is, and this is worth putting a pin in. He talked about UFOs with Edward Teller, who invented the H-bomb. That's like a known value, right? We have letters with them talking about UFOs. He was also part of something called QFOS under J. Allen Hynek. So there's that too. So,
those conversations with UFOs, Sir Tim, were they about specifically UFOs showing up with the H-bomb or the nuclear bomb tests?
No, the letter, the smoking gun letter there was a letter. Edward Teller let him use a couple of photos of like Teller for his book, right? And he wrote him and he said, thank you for letting me use those photos. This was a book that never got published, but he said, thank you for letting me use those photos. Oh, and by the way, you know, as we've been talking about, there's a UFO in the photo that you sent me behind you. You know, like, so
Wow.
that my takeaway on that was that these guys, and these are the guys,
But
right?
was that book never published, or is it sitting next to all of the other information that's locked away somewhere next to the TR3B, wherever it may be?
Could be, but my takeaway was these are the top guys involved with the nuclear program, and they were into UFOs. I think that's one thing that we can say with certainty. Now, if they knew anything more, that I don't know. I wish I had something better for you guys.
That might have been what inspired him to work on fusion to begin with. So
I think
it's all
the fusion is about creating antimatter.
Yeah,
for these
it was interesting. It was an interesting time. I mean, you know, but
have you seen the Bob Lazar tapes from what's his name channel? The name he just released, Anthony. I forget his last name. He just released the Bob Lazar tapes that were hard to find.
Well, he did. There was that movie that came out a few years ago. Yeah, I know Bob from way back. But
I was watching it again. He said that they were creating antimatter with a fusion reactor, for the gravity generators. The antimatter would hit would fall down, and it would create a fusion reaction that would create so much heat, then that heat would be distributed onto a 100% efficient thermal electric generator, which is hard to believe exists.
I mean, if you believe Bob, right? Which, and that
a lot of skepticism right there for sure.
Well, hey, a 100% thermal electric generator is hard to believe. That's the only thing that's hard to believe. The rest of this stuff is, but it's something that's hard to make too. I mean, almost impossible to make something like that without novel materials that we don't have here, or we haven't found yet, at least, that are here.
So with Winterberg, all of his drawings and schematics. Sorry, I didn't have my headphones on, right? All of his stuff was definitely human. There wasn't any, like, just from looking at it, like when I was looking at it, none of it looked like you'd pick it up from ET. It all looked like human type fusion designs, you know. Some of it was really advanced. They had some really interesting stuff. Like, I mean, he had stuff that would absolutely fit with the TR3B, right? Like, you know, and again, Jared can talk more about that, but like micro fusion propulsion stuff. I mean, it was all there. And
Jeremiah's mentioned like acoustic aspects of levitation regarding parts of the TR3B system in discussions with me in the past. Have you heard anything like that, Tim, or no? Just a few.
No. This was fusion, micro fusion explosions. He did get into aether theory. He wrote a book on aether theory. In fact, Jared's going to scan that and try and get that out to everybody.
Microfusion.
Aether theory?
Interestingly, he wrote a book on aether theory, isn't it? Which is weird because he was like establishment. He was an establishment guy, but he was fighting the prevailing establishment. And then let me see. They had some interesting stuff, like you can use X-rays to suppress a superconductor, and then you can, right, and which is just, you know, little, like, these are like little engineering hacks they came up with, right? Like, and so
Hutchinson-esque ish kind of.
Well, we'll get into it on APEC, Tim, but I use the instabilities that electrical engineers purposefully try and get rid of in their circuits and in their systems because it blows them. And I took them all, put them together in order to create a working system. So,
well, this might be an aside, but you know, when I was doing this, goes back to a Philadelphia experiment story, and I was working with James Coram and John Daring on it. And John Daring worked at a defense contractor down in California. And Gerald, what's interesting about what you're saying is he made the claim that these unified field theory effects, or like torsion shear, which might be what's going on in the Graviflyer, The claim that he made was these show up as instabilities, and electrical engineering got rid of them in the 1930s. They designed them out, right? Because, like you said, it like you get fields that collide, and it creates mystery losses in your motor, or it blows your amp, or you get these weird nonlinear effects. And he was like,
parasitic capacitance and dichotron instabilities, and absolutely.
So stuff like that, and maybe not all of it, I don't, but from what he told me, and this goes back a ways, he was saying stuff like that, some of those are actually unified field theory effects where you're losing energy because you're changing the vacuum. And he's like, so it looks like you have this problem with efficiency, but he's like, yeah, it's because you're spinning the aether with you. And he's like, but if you do that the right way, you can create really big effects. So
yeah, I don't use one, I use them all.
Right.
Yeah.
Right.
The more extra inputs of cohesion and alignment in the fields and the waves interacting, the amplifying the effects of it. And it was funny, Tim, you appeared right before I was talking to my dad about the last APEC, where Drew was talking about how he got a little bit of extra overpower after his experiments. And it's like he's wondering where it's coming from and stuff. And it's like these guys here, their engineering minds have been like trying to harness those different extra energies and fields and stuff and put them into usable schematics for a while now. And could be a nice blend of it all.
Absolutely. I'm at the point now where I can control heat in my primary, my secondary. I can make the system go absolutely cold. I can move the heat around to different pickup coils on the outside, or I can turn the system on and take a lighter and put it in the middle of the open core coil, and I'll get voltage on my pickup coils on the outside.
So cool.
That is
a very neat system.
That is cool. Do you have like a measurement tool? You know, like they have the thermal cameras, or like that would be really cool, especially
I have the thermal laser, and I have a infrared camera as well that you can look at it when it's working. And the funny part is, I've done a video.
I saw that video.
You seen that? You turn the coil on for
it was a little cooler. I saw that.
30 seconds, and the temperature goes down, and then you shut the coil off, but you can see the resonance in the infrared camera, and the coil's not hot. It's actually cooler than the rest of the room.
It's not typically normal for a coil to get cooler, but to stay at the room temperature, that's normal, or get a little warmer.
Well, but maybe the thing that I wonder about, like, so Searle effect is supposed to run cold. A couple others are too, right? And one of the ideas was that they supposedly, I'd read that they run cold because it's taking energy from the surrounding environment.
Endothermic.
Yeah, it's cold. It's a cold energy.
I think it's got.
And the thing is, this is a marker for free energy devices. I believe. You know, when looking for this as a marker.
Because that's your energy source where, boom, you're not breaking the second law right there. It's like you're taking energy from the environment, not the vacuum, the environment, and turning it in.
Yeah, but remember, heat has to go
Lenz's
somewhere.
law has no room here.
Remember, heat has to go somewhere. So either you're using the vacuum to put that heat in there, in a sense, or you're using that heat along with the system creating the voltage from that heat into a load. So you're cooling your system down, but the heat from that system is going into your load. Otherwise, it wouldn't work, because that's how I can balance my primary and secondary, by using the load off the back end of the circuit, which is part of it. Right?
Yeah, that's interesting, man. That's really interesting. It sounds like you're like right on the edge of a bunch of stuff, you know?
Yeah, today I made my coil levitate once from the primary, twice from the secondary, and then I made it hop 8 inches and then come down to 4 inches above the original levitation point. And then I was able to turn a dial and slowly make it come back up and slowly make it come back down. So Yeah, crazy stuff.
I was-
We're
I was
on the
telling Nathan.
edge.
I was telling Nathan earlier, Gerald, that you're gonna invent a new way for us to play horseshoes.
Yeah,
I saw that.
Yeah.
That's cool.
we're gonna get
While we
Shawn
have Tim and
tomorrow.
Shawn together, Shawn, do you want to talk a little bit about what you've discovered with Tesla coils and how it's like applying to the Nathan as well with the gravel flyer? Because I know Tim, you've been following the gravel flyer a lot. That
Shawn's way of building a Tesla coil is completely outside the box, and it's like next level.
Yeah,
Absolutely next level.
you won't find anything else like it on YouTube.
With him building the heart of a ship, we'll be there in 6 months, Tim. I'm telling you. Go ahead,
I
Shawn.
appreciate
Sorry to
that. No, I appreciate that. If you're interested, Tim, I did a 45-minute presentation at the start of this cast, and I go in a bit more depth on what I'm working on. But basically, I'm designing Tesla coils of immense power, but they're small. So I have this 4-inch diameter sphere that I wound with 3,000 turns of 32 gauge wire. I submerged it into an epoxy in a vacuum chamber to remove all the bubbles. And then I made that the secondary of my Tesla. And then I created a concave loop of 1/4-inch pipe as the primary of the Tesla coil. And what I'm finding is I'm able to get 3-4 times the size of lightning bolts flying out of it. And yet, when I tune it, there's no radiant energy from the sphere. Here's an example.
Wow.
So it's not quite tuned, but it's almost tuned. So this is almost as efficient as I can get it. But this is just one of the outputs that I can achieve with the goal of getting to 1 million volts, yet put on my desktop. One of the fascinating behaviors is I encased one of my coils into 1-inch thick epoxy walls, and yet I can see the plasma discharge go right through,
The epoxy.
and as if that epoxy wasn't there. And I don't know if it's quantum tunneling. I don't know. It's just absolutely a phenomenon I haven't seen. But you can see here also, this is a top view. I'm putting my camera only about 4 inches from the top. Not my camera, my phone. And yet there's no EMP. There's no electromagnetic pulses that would normally affect electronic equipment. And it's because this sphere, this unique shape, seems to be efficiently processing all of the electromagnetic radiation to give it into this clean discharge. And then Nathan pointed out something really interesting, and that is if you look at the swirl, there's some effect where maybe it's drawing energy in versus pushing energy out.
Could you do a sphere? Let's see, I'm now messing with my own head. Could you do a sphere within a sphere?
And have one of them the primary, one of them the secondary, and have it as a Tesla coil?
Yeah, like you've got the primary sphere there, right? What if you were able to do that secondary as a sphere around it? Then you could make it really small, and then maybe you could pop both of them or something. You know, that is really cool.
I appreciate that. That's a really interesting idea. I'll definitely put it on my list of testing. Thank you for that.
Yeah, well, I was just one. The other thing, somebody was talking about this earlier today. They were saying that the Tesla had the ball on the output, right? So that it would be interesting to see if you were able to put this entire thing in a sphere. You could make this whole sphere like the output instead of having a pin, like
yes,
And I'm not sure what that would do, but like probably you'd have a lot more field output and less like sparks.
Well, you'd have more field compression by far. Yeah.
It would add a tremendous amount of capacitance, yet with no pointy edges, it would hold as much charge and as much energy as it could, and that would probably have effect on its output. I wouldn't get any discharges like this, no sparks, but
Yeah.
it'd be working on the reverse of trying to push out as much radiant, invisible energy to power remote sources or remote objects.
Yeah, you'd have a massive field, right? Yeah.
That's what I'm thinking, because I can get a massive field around this when it's out of tune. That's another one of the anomalies of this. When it's in tune, I get no fields. That's why my phone can hang over these lightning bolts. But if it's out of tune, it radiates energy more than the average coil.
Yeah, that's really interesting. It's super cool. I've never seen a spherical Tesla coil like that.
Thank you. Nathan, can you pull up the picture where it's in my hand and you can see the epoxy, just to give Tim an idea of what it looks like physically?
Give me a second.
I got a question for you, Shawn.
Sure.
Are you grounding your secondary out at all when you do your experiments?
Yes.
So where you put your ground, do you ever make identical opposite coil?
Oh wow. Wow, that's
And
beautiful, man.
run your ground for whatever distance you decide in this experiment, and take your opposite coil that's identical to your first one and set it up with a capacitor to ground. And I'm betting that you're going to get more energy than you think of.
So they basically have an inductor capacitor at the same resonant frequency as the sphere, and then see if that it's able to transfer that energy out through the ground.
Exactly. Ground both systems the exact same way, just to test to see what your distance could be. And using your ground is actually your power transfer.
Well,
that's a really interesting idea. Thank you.
Yeah, that is beautiful. That is absolutely beautiful. So with the way that you have this wound, then when you do the secondary around that, you're I think you're losing a lot, because you've got that plane, right? And the sphere is kind of, but yeah, it would be really interesting to see if you could go in a sphere around that.
Yeah, yeah.
Maybe you would have better transfer. You know what I mean?
Yes, that's kind of why you'll see a top load on Tesla coils, because it builds a bigger charge before then it lets go. What you're saying is basically build a top load, which is just an external sphere, and that would build a much larger charge to see before it discharges. So that's a really cool idea, Tim. I appreciate that. I'm gonna definitely try it.
Dude, that's beautiful. The way that you wound that's beautiful. That's like a work of art, man.
I appreciate that. Thank you so much. Nathan, could you show them the coil video that I roll? My latest, the black one?
Yep.
Yeah.
Cylinder.
I was just trying to show them the primary and secondary you put on this.
Oh, yeah. Show them how this, how it's not working right.
That's so beautiful. Wow.
See that? That's some serious plasma discharge right there.
Yeah. So it looks like it's
plasma time, guys.
It's winding.
Yeah, but you see when it sparks over, then the outside lightning gets way bigger.
So your secondary is shaped like a standard secondary Tesla coil, but it's epoxied in a sphere.
Correct.
And it coming out the tip, you have the.
So if you were able to epoxy that, secondary, right?
Yeah.
If you did the secondary, then maybe you can get rid of that arcing over.
Well, it was just some adjustments, and the arcing over stopped. But the outside sphere that you're mentioning, to see if I can, that's just fascinating. I have to try that. It's just
dude, I think that's beautiful, man. That's.
Thank you. This is 5,000 turns of wire
Yeah,
on a cylinder. And what you're seeing here is when I change to the next level, as I wind 50 windings per level, and it's 100 levels, that's what this gap is here for. And then there's a little video where I roll it because it's translucent in the light. And I think it's the next one after this.
Yeah, give me a second.
It just kind of gives you a sense of what I'm working with, and it has this such an aesthetic quality while it's also functional. And also seems to just be breaking the rules. I don't know why. It's very fascinating.
I have a suggestion for you for an experiment.
Sure, I got my notebook here.
If you can find a large enough glass borosilicate bowl and put it over your coil, just be
your
ready for
secondary?
the outcome, because you're going to contain your field and your electrostatics, and I think your wireless ability is going to go exponential. Could be wrong, but it's worth testing.
It's definitely
If it's glass, you will amplify the aether energy.
Borosilicate glass. There's a reason for that.
So the you would just leave it on. Maybe you could pot. Do you think you could pot it
That's
inside the
interesting.
bowl?
I'll have to try that with my coil too.
Say that again, Tim.
Well, like, what if you had a couple of bowls to do your sphere? What if you had a couple of bowls? You could just drill a hole for the wire and then just pot it right in the bowls.
Interesting.
It sounds kind of similar to Dan Foster's like double circular bifilar. No, that Jeremiah built one of. You know what I'm talking about, Gerald or Tim?
His was a little different.
A little
The
different.
way he wound his was unique, so it's not quite
Thanks,
the
David.
same. It's spherical, but it's not quite the same. It would do different things. The fields are compressed in such ways that it's hard to actually imagine for me, but unique. Like, I can't wait to see the whole thing done.
There's so much to coils.
Yes.
And
Yeah.
I love them.
He's epoxying them to keep the high voltage from the atmosphere.
Wow. Yeah. See, that is so cool. That is so cool.
What is that?
Not easy to print, not easy to design. It's 100 grooves at 1 centimeter depth. Just fresh off my Bamboo Labs printer. In the next slide, you can
shout
see
out Bamboo Labs. You know, if
That's
you
your-
want.
I love to get
stuff for
access
yourself.
to that file for 3D printing, if you don't mind.
Yeah, I'm keeping it on a friends only basis. So Ben, I'll be glad to send you one.
I appreciate that because that doesn't look like too involved for me as a project.
It's a bear to wind and it's a bear to epoxy, but it sure is pretty. You're a awesome coiler, Ben. So you'll have no problem.
Yeah, I'm pretty experienced with these coils, at least the rodent coils. I'm looking to expand to different shapes though, and Gerald's been very kind and helped me with that too.
Cool. Yeah, I have the donut or the toroid and a sphere. Those are the ones that are on my list right now. I haven't finished testing the sphere, and I haven't finished winding the toroid yet. Toroid is so hard to wind. I don't know. You've seen the donut?
Yeah.
I'll
There it
say
is.
this, Shawn. You've given me another perspective on how to wind these coils. I'm going to try something completely new I've never done before, just because of the way you've done your system. It's just phenomenal.
Thank you. I appreciate that.
We'll see what the outcome is. I'm at 170
And,
different coils at this point. So
Very
see.
cool. Your coils
yeah,
are
through
amazing.
experience, you get little tips and tricks on how to wind them. I'm sorry, you said what?
Yes. I just said Gerald his coils are amazing.
All of
Yeah,
your coils are
Yeah,
amazing.
he's saying toroid coils are hard to wind, and that's what Gerald's winding there.
Right.
Yeah,
exactly.
it requires experience. You just got to do it over and over again until you get your rhythm of it.
Could take as much as
There
3
it
months
is.
for each coil.
This is my next level. So I'm putting rectangular wire on here. And so what that means is instead of a 32 gauge round wire, like my other coils, this one's 32 gauge thick, but it's 1 millimeter wide. And so what that means is I can still put 5,000 turns of wire on that 6-inch coil, but it's going to allow me to have 5-6 times the amount of current. And current is really the name of the game when you want to see a lot of electrons flying out of your coil. So this is where I'm kind of thinking I'm going to fudge it. And I didn't mention this in the presentation, but the same distributor here They also make 99.9% pure silver magnetic wire.
Yeah, I was going to ask about that. So if you did silver instead of copper, what kind of results would you think you'd get?
Higher efficiency.
Yeah.
Depends on what you're hoping. Go ahead. Sorry, Shawn.
No.
I mean, aside from
An
being like
empty
totally
wallet
poor,
at
right?
the end of the
Like,
day.
Yeah.
Besides it being the most expensive coil I'll wind, it'll be money in the bank too. You
So
know,
you get pure gold
Money in the
wire to
bank,
do the
yeah.
next
A
one,
great way to
right?
hide your cash.
that's right.
So
There's a
is
lot of
there?
coils.
Are you getting that from Amazon, or is there a specific distributor? Because I'd love to order both the rectangular wire and the silver.
Well, I'm looking for somebody to actually go halvesies or something with the silver because I just can't afford a 20-pound roll. But yeah, if you're
You
interested,
can all go 120s into it, so get a couple coils each out of it.
yeah, I'm totally open for it.
Yeah.
So what I was ordering off of AliExpress.
Just make sure you practice on a copper wire first. You don't want to wind with a silver wire and screw it up.
Oh yeah.
What's up, Darren?
Always.
What's up, Anthony?
That's
So
just my 2 cents. That's all.
No. So a salesperson from China somehow got my email from AliExpress and said, "Hey, don't worry about AliExpress. You can order straight through me." And at first I was like, no, I don't know. And so I told my wife, "Look, I'll take a chance because I want that rectangular wire." Yep, came in just like I wanted it. So I ordered a second coil, 20 pounds. Listen to this, 20 pounds of copper wire for $160.
Oh,
That's cheap.
beautiful.
You can't even get 5 pounds.
Like the Chinese
China?
military researchers want you to succeed and afford
How
the
pure is
next
it? I mean,
level of
it's from
experiments,
China.
right?
Are they
Like,
synthesizing it?
Oh my goodness, I didn't think that way. Oh my goodness.
you never know, right?
Right.
Yeah, if they
right.
could be, it could be really cheap because they could be growing it or synthesizing it, transmutation or whatever.
China mixes aluminum in a lot of their metals. They've been doing that with the Tapcons, or they're supposed to be 100% steel, the Tapcons, but if they break, there's aluminum in there.
So I don't know if you guys are interested, but I can do a few picks if you want. I got to test drive the Cybertruck.
Ooh.
Oh, heck
wow.
yeah.
I'll do
Look
a
at
quick
that. Our Tim Ventura competing with the Chechen warlords.
That's
Also
right.
test drive in, right?
Because I have a Model 3, right? I have a Tesla Model 3, and it's little, but I love it. I absolutely love it. Because gas in my area, because I'm near the Canadian border, gas is like $6 a gallon. So I had to go to the dealer.
Alberta border, man. It's way cheaper. We're the Texas of Canada.
And so I got to test drive the Cybertruck.
Oh, that's nice.
Yeah.
Good tune.
Oh, okay, you can hear it?
It's
Okay.
auto drive?
Yeah, we can't. Yeah, this is going to get us flagged.
Yeah, you might want to mute that.
Is that the stereo in there?
Uh-oh.
That was the stereo. So this is
Was it
the
Boston?
sliding thing on the back. And that's it. And then this is the new Model 3s. So that's the deal. This is down in Seattle.
Wow.
Yeah. So the Model 3 is I really like those, but the other one is too big. So that's all I have for photos. But
that looks fun.
That's awesome, Tim.
Yeah.
Absolutely.
So I would say my takeaway on that is I mean that's a massive, it's a giant vehicle. Like it's big, right? So
Wow.
if you're used to like F-250, F-350, then you'll probably like it. But if you're used to driving something that's like normal size,
250, 350, okay.
Wow.
Because I sat down in that and I was like, because it's like you see it online, it looks really cool, right? And I was like, I want one of those, And then when I sat down in it, I was just like, no way. There is no way I would buy this. It's just too big.
Wow.
Too bulky to turn like it's square, no? Yeah.
Well, okay, so I have a question regarding this because it's like literally the day before the Chechen guy came out with the whole militarized Tesla tech or truck. There was an American company that came out with 3 different kits for covering like the Tesla trucks, fully militarized and stuff, and we're like selling it and like promoting it. And it's like, so is this like the future? Are they just gonna be like what? Is like the Tesla truck the new Hummer, or what's going on? The drone.
I mean, so remember when they came out with the Hummer 2 and people, they had the same reaction that I did when they came out with that thing like 20 years ago. People were like, yeah, you know, it's really cool, but it's too big, the whole 9 yards. But what's interesting is it did kind of change trucks a little bit. You know, it made them a little bit more rugged. You know, people, even though it didn't, I don't think it sold that well. It kind of, the truck industry kind of followed a little bit. I'm wondering if that happens with the Cybertruck. I'm wondering if, like, even though it's not, I don't think it'll be a giant seller. I wonder if you're going to see regular trucks start to go that direction a little more. I don't know.
It depends on how
Is it
many
self-driving?
charging locations they make.
Is it? I think it is, or it's optional. I don't know.
So it's potential drone takeover in a
Nope.
9/11 style conspiracy-minded individual. To say
There's multiple companies out there offering conversion kits for F-150s and F-250s right now. So, yeah, it could become a little bit more mainstream. Hard to say.
Yeah,
Yeah.
no, thank you.
Well, when we were in Reno, we had a Kia EV, and that was little, right? But it was like, you could kind of tell when you got in it. Like with Tesla, they design it electric first. It's like, we're going to create an electric car, and everything kind of works good. But like with the Kia, it's almost like they took a regular car and they just ripped out the engine and put in their electric system and changed the controls. And we had so many freaking issues with that thing. I mean, just little stuff like you shift into park and the parking brake comes on automatically, but then it doesn't release automatically. And it's just like, you know, Jared would get in it. And like, I thought this was me. I was like, maybe I'm doing something wrong. I shift into drive and it won't shift. And it's like parking brake engaged, but then it wouldn't disengage. And I'm like, okay, I'm retarded, right? I'm doing something wrong. So like the next day he got in the car and the same thing happened to him. And I'm just like, okay, it's not me, it's this car. It sucks. So
There's been accidents like that, I heard.
It sounds like their ground, they had a problem with their ground and their electrical was bouncing all over the place.
That's a recall.
they had weird stuff too. Like, and then they had a nav system, but like for most nav systems, it either pops up, right? Like you're even Garmin or whatever. It's like, do this next, or else it's a list that scrolls down, right?
Oh,
they're scrolled up from the bottom. And so like I'm looking at it and I'm like, okay, do this. I'm like, what the hell? And so
and it always takes you to the wrong place.
yeah. I would be careful with EVs because a lot of these manufacturers have not figured out what they're doing yet.
The thing I can't imagine is I'm trying to visualize driving with a square wheel, and I can't, or a rectangle shaped wheel.
It's a drive-by-wire, right?
Rectangle shaped
The
wheel.
strange driving is drive-by-wire.
Yeah, the wheel is rectangle shaped.
what?
On the
Maybe
Cybertruck.
no ones. I think
Here,
that
let
might
me
be.
Google it. Why the square Tesla steering wheel?
Oh, the steering.
Yeah, is there a reason for that? Maybe it has a practical application or
Steering
something.
wheel, God.
Okay, Elon Musk says the flat
don't know, that
bottom
just would-
rectangular shape looks cooler and makes it easier for drivers to see the instruments.
Oh, that makes sense. Okay, never mind. Yeah,
But it
because
doesn't say-
I'm just trying to picture driving with a square wheel. It seems a little odd, but I knew there had to be some kind of reason for it.
Are the edges smooth?
Well, everything in the interior should be. Oh, here we go. Yeah, BurnEye wanted me to pull up some videos, and I didn't have access to them, Nathan.
Oh, sorry. I'll let you
Of,
guys finish your
Shawn's.
conversation. Go ahead.
Oh, okay. Yeah, no, I was just saying, like everything in the interior, they like to design it with a purpose, you know.
So there's another article here that says Formula One drivers can recognize the wheel's orientation by feel when it's square, right? I don't know that. I think that's bunk because most wheels you can kind of tell, they've got the notches for your thumbs anyways. I don't know.
Right.
Again, I
think it's personal
You
preference.
don't drive with the square wheel, so I don't imagine.
Oh, so these manufacturers are appealing to race car
Bernie's not a
drivers.
square.
I want a triangle wheel now, just because you
when
guys
you're
are
rolling your round, the universe spins. There's just something to it.
That's very
But
true.
some of that stuff, I mean, some of that stuff is what you're used to, right? Like I heard a long time ago, somebody came up with a joystick control for a car. I'm like, I couldn't do that either,
Yeah, I don't see that happening.
There's like an age limit for some of that stuff.
Yeah, no, thank you.
I don't know. I'm going to stay as young as I possibly can. Even if I'm 75, I'm going to jump out of an airplane. I mean, life's short, right? Take it one day at a time and do the best you can with it. That's all.
I'm not getting in an airplane. No, thank you.
How about we take it one step further? We're
I'm
going
with
to
you
jump
on
out of
that,
a
Nathan.
Graviflyer.
Oh,
I'll jump
We had a
out if
gravel
I have
flyer.
to.
We had a gravel flyer. I wouldn't jump out of it. We'd just be going somewhere.
Dude, I'd have no problem getting in a jet where I'm in the cockpit, but in an airplane, no, thank you. I want to be somewhere close to the controls because I don't trust a lot of people. And I have no problem going out cold in the middle of that flight. You know what I mean? As he hits those turns too fast, not a problem.
Hey, Nathan, you know what my
I hear ya.
T-shirt says? I don't trust people. I don't trust words. I only trust patterns.
Yeah.
cool.
Available now at my merch shop.
There's a
Yeah, you
plug.
guys want to play this? Check this out. This is also cool. This is one of his designs here. This is a handheld Tesla coil.
That is cool.
Just a plain blank.
Yeah, that's
circuit
neat.
board blank. The electricity seems to know where ground is.
That's
This is
insane.
my
Yeah,
my
wants to go
4-inch
to Mother
coil.
Earth.
Yeah, that is so cool.
Should do that with a vial full of like a bacteria or something,
Oh, that's interesting. That's pure continuous wave electricity.
Or tadpoles. Okay? A jar of
Right.
tadpoles.
Tadpoles.
Just to see. That's interesting.
I mean, if you can't do the electron microscope, then yeah, tadpoles.
Just do it
Speaking
to
of
some,
tadpoles, I got some in my yard right now.
do it to some pond water that has a lot of organisms in it.
I wonder what would happen if you pre-ionized the air. Would you probably get massively larger fields, right? Massively larger sparks.
I think so because ionized air has a lower resistance. So, yeah, I don't know if you've ever seen plasma go through a partial vacuum. It probably have something like that effect where it would just double or triple in size.
Oh yeah, yeah.
Like the star in a jar thing.
It's cavitation.
That
Yeah, that is so cool.
that's an
Gentlemen,
undesired effect.
I gotta bail out on you for tonight. Thank you for having me on. I appreciate it.
No worries, brother. Thanks for
it's
stopping by, Tim.
Nice meeting you, Tim.
Yeah, thank you, Tim.
Thanks
Yeah,
for coming.
have a great evening, guys.
You too.
You as well, bro.
Take care.
Oh, that was awesome.
You know what we
Always a
need to do,
pleasure.
guys? At the end of the month, we'll see if everybody who came on wants to come on at once. You know what I mean? I think that'd be cool. I think we could put something like that together. Because we had
Sure.
some fantastic people come on, man. And just a cross conversation, I think would be
Mhm.
amazing.
The
Yeah,
ultimate
all these
Fringe
minds
Think
thinking
Tank
outside the
episode.
box, conglomerating.
Yeah.
Forgot about it. We're gonna be
Dangerous
there.
thing. Things are being built. Fields are getting stronger.
So Nathan, I need a hand on a circuit later.
Yeah,
'Cause,
I got your message.
Yeah, I figured out how, on the last video I did, how it hopped once, hopped twice, and then I made it hop the third time, and then
you hold it up.
Yeah, and then it stayed there. Okay, I was saying this to Tim earlier. I'm not sure if you're around. I figured out how to make it raise slow or lower slow or go to the middle of to where it was.
Okay.
But I'm blowing variable resistors like crazy, and I need some help on my math to figure out what I need to make that sucker balance with its resistance, if you know what I mean. And I have an idea where I'm not using a variable resistor or resistance at all. Sorry, I'd be using resistance, but not a resistor. So something I want to discuss with you in that as soon as we can.
Might have to bring Shawn in on that. I'll tell you what, Shawn's the man.
Yeah.
Appreciate that.
You're the circuit guy, Shawn? Is that it?
Gerald, those potentiometers don't really do very well. They burn out easy.
Oh, yeah, you should have seen the way this one lit, man. Lightning underneath. It went and then smoke just like
I burned at least a dozen myself.
Yeah.
You're talking induction and resistors and capacitance. Shawn's the guy. He'll calculate it real fast, and it's pretty easy.
You could put a hardwired resistor before the potentiometer.
Thanks,
to
Nathan.
protect the potentiometer. You do that,
I'm gonna have to pick your brain, Shawn.
Yeah,
I know what you're saying, Mike. I have a different idea, and I don't want to let the cat out of the bag until I talk to Shawn and test it.
Sure.
I'll show you this cat, man. This is gonna be crazy. I love it.
Sounds awesome. Are we connected on Facebook? Are you guys in a part of the Graviflyer Facebook group?
I can't get on Facebook.
But I'm on Facebook.
No, but I'm live on Facebook as one of the streams, so I can share this to that afterwards.
Oh, you're awesome. I was just thinking we could all connect so I can have talk to you guys over Facebook Messenger. That seems to be easier to connect, so I can send videos or photos, or we can collaborate. I'm actually collaborating with Charlie C right now. He's sort of my guinea pig and getting
I sent him the link. Message his ass and tell him to join, Shawn. Just kidding. Not kidding.
It would be great to connect. So you guys part of the Facebook Graviflyer group? I know you said no, Gerald.
No, I was hacked.
Facebook.
I was hacked. I can't
not.
get Facebook anymore.
I'm there anonymously, so I mean, if you want to come on anonymously,
you can have an anonymous account on Facebook now. They never let you do that before.
Yeah, I can't even get on.
I created an alter, just a fictitious person.
I tried that.
Yeah, I got a second Bernard Conkin Facebook account that is a picture from the 1800s of some Mexican ranger dude that somehow looks identical to me, and I created it on an old phone, and then it's then I lost control of it, and now it's I see it and I get notifications, and there's hundreds of my friends messaging me, and I can't do anything, and then it's
oh, that's
I get mad. I'm it's not me, man. It's not me.
Can I ask a favor, Bernie?
Yes, sir.
Can you just take the camera and do a little walk around your room? I'm so fascinated by your art.
Absolutely.
It's so cool.
Yeah, that's a good idea. I like that.
Yeah, you got to see this, Shawn.
You have an awesome room.
Thank you.
Wow, that's amazing. And that's all your artwork, huh?
It's majority I got commissioned through my clothing printing business done by different artists that I've worked with. Myself can't claim to have painted it or made it all. Not that talented, sadly, but definitely great collection.
I like the choice of colors.
I love the colors. Thanks.
And I love that Tesla coil in the background with the bottle.
Right? Yeah, that's awesome.
I was thinking about making one with a Nuka-Cola bottle.
Well, and then you got
colors go
Einstein
together,
on tattooed up on $100 American bill and Tesla with Wardenclyffe Tower in the background.
Got Einstein there in the back, black and white.
But he's got a colored tattoo. He's got a sleeve, right? And he's on the $100 bill. He's
yeah, I kind of see that. Yeah.
right.
Nice.
Working at the old patent office as the old commissioner. Eh? Anywho, well, thank you, Shawn. I've got a lot more, but that's for another day.
Can't wait. That's great. I've always wondered. So I've been an outside observer, so it's nice to see it up close.
Okay. Well, give me a couple minutes and I'll mute my other speakers and join from my phone, and then I can give you a full tour, I guess, then.
Sounds
I think
cool.
it's clean, and I think it's clean enough of a studio. I can put her on live cam. All right, so I will be
good.
back.
Okay. I also had a question for the group.
Go ahead.
Could you maybe just go around and tell me a little bit about yourself? I'm sort of from the outside.
What are you, out of the U.S.?
Just like a 2-minute introduction bio of I'm from here and I do this. And
I'm Mike from Miami, Florida. I've been an electrician professionally on and off for the past, I don't know, since I was 16, 50 years old.
Wow. Awesome. Thanks.
And I'm an ITT grad from 1997. And I'm rusty with electronics. I'm that rusty, 1997 rusty.
And you make transformers, I think I heard in one of the videos.
Pulse motors right now. And the Bedini SG circuit is, is one of the things I make, and not really much else than that. I can make whatever I need to make. I've made a binary clock, a wireless video audio transformer, transmitter. I made a phone tap for FM listening. If you want to spy on somebody, you put this little microphone.
Oh, Mike, we need to talk off air.
It's just an FM channel.
Very
cool. It's
cool.
all circuits. You just read the circuit and build it like what you see there. You don't even ask a question of what it does until you're done getting it working, and then that's pretty much how most technicians handle the circuits. Is they don't even ask how the circuit works. They just go at it. Okay, build the circuit.
Right.
And if it don't work when they're done building it, they don't ask how it works. They look at their mistakes. They look for their mistakes. They got something backwards or a short or an open or whatever. And then you keep doing that until it works. And then after it's working, then you ask how it works. Then you start, you don't have a choice because you got it working.
Sure. Thank you, Mike.
The real questions
How
start
about you, Ben?
running through your head after you get it working.
Thanks for that, Mike.
Yes. Yeah, thank you, Mike. I appreciate everybody here tonight. I'm the Benefactor. I'm an independent researcher looking into various areas of forbidden knowledge and forbidden science, things that would challenge the status quo, macroeconomic status quo. And, I have a bunch of highly produced videos trying to trigger the algorithm and get this information out. I started a media outlet on YouTube called Beneficence TV with that goal, trying to disseminate and demystify and deconstruct some of these more controversial topics like 0-point energy and anti-gravitics. I did end up doing a lot of research into the rodent coil because I wanted to build my own system to see if these things actually work. And in doing so, I did a lot of research on the Nunez's and First Stop Energies. And as you know, they disappeared or went off the grid around the end of 2022, beginning of 2023. So, and a lot of their videos had been taken down. So I had to kind of reverse engineer what they were doing. And I did, and I got about 155% efficiency And when that happened, I was like, wow. Like, yeah, I couldn't believe it myself. Like, it took me a while to come to terms with what I was seeing. And then, you know, I put out the video, and, you know, Bernie invited me on to demonstrate the coil. And here I am now with this amazing team.
Awesome. You're really good at what you do, Ben. You're the editing, the recording. It's just second level.
Shout out to Ben.
Well, thank you. Yeah, I'm just trying to trigger the algorithm. You know, we're all conditioned in this era to consume data and information in a specific way. So, you know, it's all about psychology, and you can just replace the word algorithm with audience, you know, as much as where
do you live?
I'm in Michigan, but as much as I tried to focus on education, you know, we are trying, you know, we are on YouTube. So as YouTubers, you know, our job is to entertain as well. Otherwise, nobody's going to see our stuff, you know?
That's true. So true.
That's why they bring me on.
Exactly.
Me and Gerald always seem to trigger the group to laugh a bunch.
The freak show. Nathan,
thank you.
Right, well, that's what it's always been about. What I've tried to do is be a mixture of entertainment and education, and I tried to do free energy Friday electrical engineering, but it's like nobody wanted to be called a freak, so that one didn't really work out. But instead, this right here group, you're the core of what I'd like to launch maybe monthly, called the Burn Conference, Breakthrough Energy Research Network Conference.
Nice.
And
Gerald's ready.
Right, just keep it open source and share all of your results, and pretty sure you're going to have NASA's alternative propulsion departments coming to you to figure out why they're getting all their anomalous results pretty short order. But yes, it's awesome times to be alive.
Awesome. You're right. You're right.
Dude,
Shawn,
hanging out with Gerald will be like the Hangover movie. That's what we'll end up like. We won't know what the heck's going on.
Going through time warps and portals, getting dropped off on different planets. Right? Yeah.
It'll end up being like a weekend at Bernie's, I'm telling you.
No, well, that's another thing. Well, that was the plan. Always was my podcast to be weekend at BurnEye, where it just streams multi-channels, like 20 different channels over 48 hours. Include APEC, include Free Energy Fridays, but have it where it's like full afternoons, where it's like just men, women, whoever working in their garages, their labs, their backyards, taking stuff apart, assembling new things, explaining what they're doing, and putting together group projects where, you know, we can start coming up with monthly projects where we all build something to test some claim, and then all compare the results, develop it together, and
that's your future, Bernie. You're going to be able to.
Bernie, if you ever do build if you ever do build anything in the electronic thing area, I think you'll like the V-gate motor.
Hey, Bernie, you could do weekend at Bernie's, and later, once we accomplish the goal, you could show the beginning, the end, and the middle. So,
well, that'll be like lifetime at Bernie,
right?
Yeah.
You're already a part of weekend at Bernie's. We're just it's during the weekdays because we take it seriously and we're working. Right?
But the V-gate motor is more hard than the Bedini, in my opinion.
Well, I got all your attention, and while I still have it on screen, I would like everyone's opinion on this, because literally on Instagram and on all over TikTok, Instagram, all over India, Southeast Asia, there's all sorts of just these double motor supposed perpetual machines, and they start out very basic, but then what really got me is that there's a couple Russian guys building the mechanics, and then I gotta find the specific video, but he's got about 20 of the wheels and the double springs going, but it's actually driving the drive shaft of a old Lada car. He's going like 10 kilometers an hour being propelled by this thing, it seems. But is it all just fake camera stuff, or is there something?
Is it moving water?
No, he's moving a flywheel with a series of springs on it, so that once he gets the motion started, the springs consistently contract and pull apart, and it runs itself. I don't know about that. The springs
is he pumping water with it, or is it just running itself?
No, I think
some are just basic running themselves. Others they have them like with.
I mean, I could explain if it's pumping water, I can give a reason, but if it's running itself, I'd have to say
there was a device that we seen
springs.
on. Well, there was a device that we seen on live stream the other night that was pumping water on Bob Greener's stream.
Well,
yeah, there's a few types of.
Yeah, those springs concern me.
Yeah, that looks a little fishy, a little bit like the.
Right.
I mean, you could balance.
I gotta find the one with the whole. Hold on.
You could balance the springs and do something like that to get more efficiency, but that's what you're doing. You're getting more efficiency. I don't know.
Right? Should we make?
If it's going to keep running, though, you're just going to get more out of your whatever you put into it to get it started. It's more of that energy you gave it to get it going is going to get used, as opposed to without the spring, less of that energy that you gave it to get going will be used, and that's
there's no magnets on the flywheel or nothing. It's just
a flywheel.
There are magnets on the flywheel. That's one part.
Oh, there are.
Yeah.
Oh. So that changes
everything.
But
yes, there's definitely a lot of them have.
I wouldn't know enough.
Magnets on all the flywheel.
Where are the? I've never seen any magnets
along all the spokes. I've seen them install them.
It depends on how he's using those magnets.
So
if he's using like the beanie, then that's possible. But for how long, that's debatable.
Yeah,
I've never seen that one.
Like Bernie said, the springs will wear out and.
Okay. You see the crankshaft there, Nathan?
Yeah.
Chime in here.
Like easily could just be a scam video, or
isn't that crankshaft design you were talking about, or they?
Yeah. What it does is it balances, so it allows balance for every time it goes around. So
right. It's like a magnetic bearing. That's good of a balance.
Well, it all depends on his tension on the springs, because it could easily drive it down or make it go.
That's a crankshaft. They're using a crankshaft there, Bernie.
No, I'm well aware of that. I'm just saying, if the springs aren't right, it has to be 100% right, or it won't work.
Mm-hmm.
That's one of those, either it balances or it doesn't. And I don't know that they put that much precision in there.
The next scam on YouTube.
Yeah, the tolerances would be really tight on that.
People driving around with spring-loaded cars, maybe just in the cartoons and
Flintstones.
It is a pickle. I mean, they're spinning up a heavy wheel, with their legs, or a pull wire or string, and that amount of force that you give a wheel, if that wheel's heavy enough and it's properly balanced, it will spin quite a while.
Yeah, exactly. And I've never seen one of those videos go longer than a couple minutes, because it's it's Instagram shorts. Like, I'm sure if it was legit, we would have 24-hour videos of that shit just going. And if it's accelerating, you'd probably. That's the challenge, to have one that keeps accelerating. It goes till it explodes, because it takes on too much force, right? Like, it wears
100%. If you balance it right.
I mean, if I had a perpetual motion machine, I would live stream it 24/7 if I could,
Well, you get a 300-pound flywheel spinning, or even like an 800-pound flywheel spinning, and it's perfectly balanced, it will stay spinning quite a while. That 800 pounds keeps its momentum pretty well. The heavier it is, the longer it will spin. Yeah, it's just the more of your energy is going into the wheel. That's what it is.
I'd have to see it in person. I don't know anything that.
Right, exactly. It's
I don't
just
think
it's
it's over,
something that's
Unity. No,
trending
I
on
think it's
social
super
media,
efficient.
so I just brought it up because it's like, don't get caught in the scams if that's the latest new free energy claim scam.
You know,
Yeah,
those
a lot of
electric-
times they'll push the scams
There it
and
is,
they'll
like
tuck
it was
these
me.
legitimate things in the dark.
No, because look,
Exactly.
put it this way.
Mike rule it in, saying he's seen it, it's fake. Exactly, right? That's why I bring it up. It's
that can't be
everybody-
free energy because as soon as you put a load on it, it's done. Those springs
yeah.
stop. It's
It's
done.
a
like-
misdirect. It's a
Yeah,
misdirect.
no, that truck was fake or a car, whatever they want to call it.
Yeah, right.
You
Like
want
it's
that
still
car to
has a
stop?
freaking engine on it. Like go.
Yeah.
You want that car to
do it.
stop? Throw an extra battery in the back. Just the weight of it will stop the whole car itself. There's no juice in there.
There we go. There we go. That's why.
Hey, we got a question from Ian, if you don't mind, for
Yeah, go
Gerald.
ahead.
Ian asked, would your explanation of skin effect and Miller effect help Shawn with his coil design?
No. I'm just kidding.
No.
I'm kidding. I did that to Nathan the other day. I apologize, Ian. I'm a jerk. Hey, you know what? Maybe. Because of the way that a Tesla coil is built, their skin effect definitely comes into play. But I don't know about dicotron instability. And the Miller effect, that's an interesting thought. Maybe.
Skin effect.
The Miller effect, I don't know what that is. What is that?
Hang on.
Yeah, what's Miller effect?
I mean, I've heard of it, but I don't quite remember or know what it is. I know what the skin effect is. It's the field running on the outside of
Apologize.
the wire.
I'm kind of overbrained today, so I had to look at my book here for explanation.
I've heard of the Miller effect.
You know what? I just added the Miller effect to my instability list, so I'm still getting up on it, but counts for the increase in the equivalent input capacitance of an inverting voltage amplifier due to the effect of the capacitance between the amplifier's input and output. I don't think it would apply to Shawn's system. The way that it applies to my system is because there's such a charge density that the voltage difference is insane. I don't know if it would apply in the same way because a Tesla coil, it's wrapped a little differently. That's a good question.
Is the Miller effect is the Miller effect all of the inductive and capacitive reactances of the circuit combined? Is that what he's talking about?
Well, between the input and the output. So yeah.
Okay.
Well, it's the capacitance between the input and output in an amplifier.
Yeah, even the inductors have capacitance. They have inductive. They have reactance. You know,
everything does.
I'll tell you something I didn't share in the presentation, but the capacitance of these coils after adding the epoxy goes up tremendously. So here you have this picofarad.
It's the type of nano coating that you're sealing it in.
Then you mean the inductance, right? They call it the capacitance of a coil. They call it inductance.
5 microfarads, and you're like, it just went up a millionfold.
Then I recant my answer, and the Miller effect definitely is part of your system, Shawn. Definitely.
Oh, thank you.
Yeah.
Okay.
Yeah, that's great.
No.
Oh.
I'm gonna write it down. It shocked me because I always take readings with my LCR meter. It's my favorite meter. I'm a meter guy, so a little bit of a spaz. But I was thinking, oh my goodness, this is a capacitor. What? Because of all the epoxy and the coil area.
The coil has capacitance, but they don't call it capacitance. They call it inductance.
Parasitic capacitance.
Yeah, that's
it's inductance. It's inductance, but it's the same thing as capacitance in a capacitor. It has a way of storing charge, just like a capacitor does.
Yes, but parasitic capacitance is the two copper lines super close together.
Exactly. Yeah.
Exactly. There's multiple lines. It creates more of a capacitance.
Yeah. On the inductor turns, you mean? Mm-hmm.
No, on the lines of
separate turns.
Well, in mine, just lines of interwoven of copper, but in Shawn's,
Exactly.
yeah, it's turns that are consistently wrapped.
Yep, exactly. Yeah,
Yeah.
so I get powerful inductances, but then the more epoxy I add, the higher the capacitive value. And I was hoping it didn't work for me. I mean, work against me. I'm not sure yet. But it's interesting to explore.
I think it's working for you because you're creating an electret to some degree, especially if you're using your system before it's the epoxy's fully cured.
Oh, interesting.
Yeah,
I definitely want to try to run it when the epoxy's gel like. That just sounds.
Yeah.
I just have this vision in my head of it breaking out into like a fractal like structures, and oh my goodness, that's such a good idea.
Yeah, I believe it would too. Yeah.
Thanks for that. It's awesome, Gerald.
No, thank you for coming on. This has been great. Are you kidding me? The stuff I've learned. Hey, Mike. Yeah, it's just insane. I love
Appreciate that. Appreciate it.
Go ahead, Mike.
Yeah, I seen that video about 6 months ago, and the way they did the video was really compelling. And then right at the very end, he just says, sorry, guys, this is impossible. I was like so disappointed.
With the spring motor?
Yeah.
Yeah. Yeah, I just think it's an inefficient flywheel system.
That's why I bring it up to the panel of, all of you, because I know and can easily debunk for all to see.
Yeah, like that video.
It's not that it's not useful. It is a very useful thing to have. I mean, it's not
like
run forever.
There is a version of that video where they have the English version of it, where they have the closed caption in English. So yeah, I watched the whole video, and at the end he says, "Sorry guys, it's impossible."
Does it even run for 5 minutes?
How you doing?
I wouldn't even think it would run for 5 minutes. Now,
would that be enough for a farmer to irrigate his crops or whatever? That's
well, he had it still connected to the drive shaft. It's just that there was something else powering the drive shaft.
Yeah,
that's on camera, not shown. Right?
There is something similar to that. The metal is called nitinol. It's a thermoactive
stuff
metal
that bends back to its shape, right? So if you have a spring out of it, so that could be something interesting.
So they were building nitinol engines back in the late 60s and early 70s. And I believe it was GE that GE was working on it. So apparently the strength of nitinol with the spring back of the action, they say as high as 50 tons.
Yeah,
so
there was
wow, I didn't know that.
Yeah, nitinol has it's a very, very powerful.
Yeah, all you need to do is cool it off to get it to bend, right?
And so all you need is to build a system where you have one tank of hot water and another tank of cold water, and then when it switches from tank to tank, it changes its shape and spins. There was one doctor who made a machine that worked. It was actually a bicycle wheel.
Yep, you've seen the same one I did.
Yeah, it's amazing. It's really, really cool. So there's nitinol, and you can buy it. It's out there. You can buy it on AliExpress. You just Google search it.
It also comes out of your toasters.
Yep, exactly. Yep.
So if it's generating energy to make, and you got your hot water hot already in your cold bucket of water, you just got to keep the hot water hot. With the
nitinol is actually what I use for my solar toaster oven and my solar heaters. That way I can go direct from a solar panel. I don't need any electronics.
Isn't nitinol sort of like a nickel?
Yep. Nickel, chromium.
Nickel, chromium. Yeah, there you go.
I think. Yeah.
Yeah, it's highly thermoreactive.
Yeah.
So very, very powerful.
Naturally found, right?
The thing is, they were working on it at GE back in the late 60s and early 70s, and they proven that it works. With geothermal, You hook up a geothermal system to this thing, it would run forever.
Right.
Right.
Yeah, sure would.
So, but do we see it out there today? Do I see it? No, I don't see it. Do you guys see it? I don't see it. Where is it?
Well, wait. Doesn't
Somebody has it.
Greenland and Iceland, they run off of thermal energy.
Yep, that'd be a perfect place for a generator like that.
Well, they have some of not nitinol, but they have coils under the ground.
But even like solar heaters on the top of your house, like a lot of people use those thermal heaters to heat up hot water. Well, there you go. Now you got an energy source for your nitinol engine.
I use it in my grow room, so
right.
Same thing.
You could use it for anything.
Yeah.
As long as you got a temperature differential.
The gas company would take over the power company with that.
I believe it's got to be about a 30% difference in temperature between the hot and cold. Don't quote me on that number, but I'm pretty sure it's close. It's got to be about a 30% differential. Yeah.
Well, so, I think the grid should utilize these concepts and make our power like
and it's
cheaper.
And the thing is, this metal's been around longer than I've been alive, and I'm 51.
Right.
Why aren't we using it?
Yeah, this metal's from the 40s, isn't it?
Probably, yeah.
Yeah. Even further back.
How long have we had?
It's a naturally found deposit. It's not something that man made. It's like nitinol is something that we found on Earth.
It's a composite. It's a man-made composite.
It's an alloy. It's an alloy. It's a mix.
I thought it was natural. I'm sorry.
You can look it up online what it's made of. It's nickel and something else. I forget. Aluminum.
Hey, Ian.
Hey, Ian, you made it.
I certainly did, gentlemen. How are we all?
About this. Look at this epic panel.
How's it going, Ian?
It's great.
All good, thank you. Bernie, how you doing, fella? You're good?
Good.
Man,
your lips aren't moving, Ian.
Mike, what were you talking about the nitinol for? Were you planning on building like a Stirling engine with it or something? Oh, and he's gone.
Oh,
go ahead.
Mike, honest.
Yeah, go ahead. Yeah, I'm here.
Mike, what were you going to use the nitinol for? The nitinol, were you going to build a Stirling engine?
No, I was just doing some research on it a while ago and thought about building one, but I just never got around to it.
It's
but
very
I know
good stuff. Very good stuff.
Yeah.
Just the way it returns to its shape, doesn't it? So you can coil.
I have no idea what's going on.
Well, it's very powerful. They said up to 50 transforms.
I'm hearing this bizarre voice behind me that has nothing to do with me. Jeez. Hang on. Okay, I'm gonna leave.
It's like an echo.
Hang on, I have no idea.
I have no idea what's going on either.
Weird.
It's Bog Irish. You're wondering where the voice is coming from.
I think it's Master Eon or Mr. Ian.
It's Mr. Ian.
There you go, Mr. Ian. Sorry. Trying to keep it straight.
Yeah, and I got some studio mics. I might bring them out.
Extra mics? We have 2 mics already.
What's going on, gentlemen?
Microphone.
I know, I'm kidding, dude.
I'm using a cheap one, yeah. I got these really high quality Russian microphones.
Wow, we all just went silent there. That's kind of cool.
we did that on Friday night too.
Yeah. Deep in conversation and then whispers. That's awesome. So Shawn was asking each of us to kind of give out a breakdown of who we were. Everybody went except for Nathan, Mike, because he just got here, and of course Ian. Oh yeah, myself. But I'll go last. It don't matter. So if we want to continue this, please, Ian, you want to go first, or Mike?
Yes.
Doesn't matter.
Do you want to?
I have no idea if my mic's
I've
even working.
fielded a couple of AIs on the Discord server with Jeremiah and Space Case and Simon C. And we're working on time and gravity manipulation with the power of
race
AI.
is
Not
on.
me.
What's going
I have
on?
no idea what this is.
So hold on.
That wasn't you?
No,
No, no.
no, you guys are mixing it up. Mr. Ian at the bottom is talking, not
That was
not
me,
Bug
yeah.
Irish.
Yeah.
Oh, that messed with my head. That's so awesome.
This is weird.
So hold on.
You
This
just
is
figured
some
it out, huh?
this is some
So-
AI thing that is talking on behalf of me.
What?
It's not
What are
you
you
at
talking
all.
about?
That wrecked my brain, man. I love it. I love that stuff. That's great. That's great.
I'm still lost.
I think from here on in, Bug Irish, we're not going to call you Ian. We're going to call you Bug Irish. That way everybody can figure this out. Because
Right, Bug Irish is your name, Ian, as well.
Yeah,
Yes.
see?
Well, okay, there you go. That's why.
That's the confusion.
Who in tarnation is Mr. Ian?
We got two mics, two
Me
Ians.
at the bottom, Mysterion.
Not a me. Who?
Oh, who am I?
Right.
Yeah, we were all describing who we were and kind of what we do and how we
Age,
got.
occupation.
Yeah, well, I did. And Bug Irish was wondering where the voice was going and going, that wasn't me.
It's just
that was me.
That's why it was confusing.
Mr. Eon has the best microphone here. That's what it is.
Oh,
Sorry.
my
Yeah, I
God.
think we broke Gerald.
He's got the best voice.
There you go.
Oh, that was so great.
Okay, so now Bug Irish needs to go. If I'm correct.
Yes.
Yeah.
Sorry.
Come on.
Oh, you're on muted. You're muted, Bug Irish.
I can hear him.
Oh, there you
No,
go.
I'm not.
There you
Oh,
go.
there you go.
Yeah, we can hear you.
Am I there?
Yeah.
Yeah.
Oh, okay. I'm really sorry about that. That was some AI thing that was talking in replacement of what I was saying in a very weird accent across everything.
Right.
I
was
had no
me.
idea.
It's creepy.
Here it says. Shawn. Say something, Shawn.
John or Shawn?
Shawn.
Yeah, you.
Shawn.
Hi, I'm right here.
Right. Your bubble around your photo actually
Yes.
moves when I'm hearing this weird voice.
Oh, wow. That's not.
Yeah, really.
That's how the
weird.
StreamYard works. It does that.
Describe the voice.
It just asked me to describe the voice.
No, Ian.
Wow.
Ian, that's me. You are having a bit of an episode here. Okay.
It's the StreamYard.
The thing
There's
doesn't
9 of
move
us in there.
around my voice when I'm speaking at the bottom there, Mr. Ian. I am Mr. Ian. That's my name. Also,
He's in the
Ian,
bottom center.
I'm in the northwest of the UK. I'm just above Southport, so just over the water from
Okay.
here. Whereabouts are you based?
I'm in Florida.
Oh, you're in Florida.
Okay,
Wow.
so-
Well, there you go.
All right.
You've done well there, mate.
Nathan, did you invite Mr. Eon in?
Bernie.
Yeah,
did.
Bernie did.
Who did
Oh.
Bernie?
There we go. Okay. All right.
Yeah,
It messed with my
StreamYards
head
are like
too. That's why I'm
you're-
sitting in the background
Eon,
going,
I do apologize. I thought you were just some very strange kind of thing talking over
AI
my
voice. No.
That
I
was
actually
totally
really speak
bizarre.
like that. That's
He
actually
still
my
doesn't have
voice.
to sound
one
human.
for the records, though. It's been
The
recorded. Yeah.
Sorry, my
Hysteria.
apologies. And that I invited a second Ian simultaneously while we had another Ian joining.
lovely.
And yes, I know Mr. Ian, he does AI work
So confusing. It was
generating
great.
with Jeremiah, as well as Ian. You never got the chance to fully explain that like detector device that you were telling me about the one time that deals with EM waves and detecting other entities or
Well,
something.
we found a device from Hong Kong. Well, no,
But
I can't
before-
remember because
before
I'm
you
in
go
the
on,
market
Ian,
for
I
it. But
just-
we found a massively underplayed device which picks up on anomalous signals. and it has a Bluetooth partner app with it as well, which is really handy. That it's just all off the shelf. It's kind of given to us. So we've built an anomalous signal detector, which tracks human targets, but it tracks human targets using a specific frequency, and we get anomalous signals in that it tracks. It's either Dopplers or we're picking up on ghosts, and they move around you. And we'll put up a video on it anyway. But it's quite exciting, and we may well have invented a ghost detector.
So,
Are you
yeah,
looking
sorry
at
to
plasma
interject.
frequencies? Are you looking at plasma frequencies?
No, I can't say anything about it. It's me, Jeremiah, and Space Case are working on it at the moment. Me, Jeremiah, and Adam.
Oh,
So
okay.
I've built the prototypes kit together here. I've got to send it out to them. So you'll have these out stateside. And I should imagine they'll go viral like a tri-field meter, basically.
Yeah, we need to make that viral on Halloween. So Halloween rollout.
Like, I'm not messing here. This is serious. Seriously,
Yeah,
it's very.
I know.
very
I
indeed.
can tell
I've been taking it around some
think-
rather haunted locations in the UK, and we've done some field testing and some recording, and we have some scary footage. Some very scary footage. With,
So I have a theory
with
on
live
ghosts.
data of the detection as well, which is incredible.
Fascinating.
It's incredible. It's just putting meat on the bones, isn't it? So anyway, I'm spoken loads. Someone else talk.
Are you sure you're picking up on ghosts, or are you picking up on resonant energy?
Theoretically,
Well,
wouldn't
this
you
was it. This was
detect-
it. There was the thought. There was the thought that they could be plasma pixies, if you like. You know,
Yeah, or vortexes that were locked in
Yeah,
place
yeah.
that haven't been exercised or grounded out, so to speak. There was a theory that I
energies
came up
all
with a
around
while
us.
back
Yes,
about that.
yeah. That's
It's
what we're
kinda
saying,
like
like plasma
ghosts.
pixies. So it's just charge in the air. So, but no, it isn't. No, that's not what this is. It's actually picking things up, and they follow you. And so we did it at my partner's her flat in Manchester, and she lives in a block of flats, and there are bits of it that are apparently haunted because it's been there for quite a while. So there's been some horrid tragedies happening in the flats, and whatever it was that I went out and field tested the equipment. So we set it up, and then I went out to the location, and she stayed back recording it, and recording the audio and recording the data from the screen as well. And it picks up on this entity as I've turned the corner, and there's a chair there. And I swear, as I was looking at this chair, it had an aura around it. And the hairs on the back of my neck went up, and I pelted it down that corridor away from that chair. And it felt like I had something following me down the corridor. One of her cats bailed it out of the lounge, ran up the corridor, screaming at the top of its voice to meet whatever it was that was coming down the corridor full on. And we've got we've got the whole thing recorded. We've got the data, we've got the moving target.
Hey, you need to publish all of this, please, Ian, because man.
Well, did you just say your cat was screaming at it?
Oh yeah, you never know the cat go like it, and the cat just went.
Oh, that goes right to my theory about animals being able to see in that second field.
It was like it came to my defense in some way, which
Yeah.
is weird.
I believe that. Like,
There's lots of stories about that. The cats do that. They'll fight off or
completely.
scare off
they'll
whatever's in the
sleep in
background.
certain zones. They'll sleep in the opposite charge zones as dogs, right?
They sleep on my workbench every time I do vortex tests.
Yes.
Well, playing back to what Bernie said about Halloween, theoretically, if it's picking up spirits, Halloween is the thinnest.
Snap! That's just dangerous.
very
All y'all
rare.
working with like
there,
portals and like energy fields, and then it's like, now let's just attach some ghost detector communicator.
It would go, yeah.
I figure it's got to be essential kit. It's
like at least some
if you go out and you've got
Ghostbusters
an EM field meter, you've got a tri-field meter, you've got like what the vibration sensors that people use, don't they? So ghost hunting kit at the moment is basically a tri-field meter if you can afford it, a crucifix,
That's
a
so cool.
torch.
That's so cool.
Nice.
But
Is the antenna the crucifix? Is that because that would make it a T antenna, and usually that counter reacts.
I had an experience like that a long time ago. But I didn't see nothing.
oh,
But
look
the
at
thing
that,
hit my
Gerald! You're
left
just
hand.
showing off now.
Is that a
And you're
trimeter?
muted, Gerald.
Mhm.
And you
Yeah.
I just wanted to show what to the audience what you meant by tri-field meter. That's all.
Mm.
Can
Very,
someone
very
explain
good
what
piece of
three
kit, but
fields
very
these things are
expensive as
measuring?
well. But very
It is.
accurate. They're nice. That's nice. Nice kit.
They are.
Did you get it with the case?
Yeah.
Mhm.
Yeah, good.
I like those
Wow,
old
look
analog
at that.
ones.
Gotta have that hard case because I drop stuff all the time.
Yes, yes. You don't want to drop that.
What are the fields? What are these three fields called that they're measuring? I know they exist, tri-field meters, but like, what are these fields? Other than
Yeah,
magnetic?
it's magnetic, it's electrostatic, and it's RF.
Radio frequency.
Yeah.
Mhm. Yeah.
I thought it was
magnetic and electrostatic.
Yeah, I thought it was the dielectric field, the electrostatic field, and the lines of force. That's what Eric Dollard says usually.
The lines of force would be your magnetic, I guess.
Yeah,
No, your lines of force are actually so what happens is when the dielectric field and the magnetic fields create a superposition where all the nodes take place, then a motion or a force motion takes place. And they call them lines of force.
We were thinking of creating a similar device that used the radar sensor that we've used, along with, say, a time of flight laser sensor and an ultrasonic at the same time. That way, if you got a reading across all three, then 100% you've got something solid. If you only get a reading on the presence sensor and not on the time of flight or the ultrasonic, then it's a plasma pixie, like I was saying before, potentially an energy discharge in the air or something, and or a Doppler. Or a Doppler.
Yeah,
I have to disagree that it's just some energy discharge in the air.
Yeah, well, I think it's ghosts. These things follow you. The things they follow you.
No, they definitely are
stand
ghosts.
next to
There's
you,
some
which
kind of
really-
entity, entities or whatever that you cannot see. They're there, and you could pick up
It's
on
vibration.
It's
everything vibrates.
You can pick
right?
up.
Never forget that everything vibrates, and if you have a vibration that could be different temperatures of plasma, because if the universe is 99.99999% plasma, then it surrounds us all the time. So
right. That's a good way of looking at it.
there is a theory.
You're totally onto something.
There is a mode of
Very much
thought.
so.
There is a mode of thought that actually assumes that this is.
I think it's like a repeat of an energy moment of time.
Yeah,
some kind of a
most
event.
plasma does appear to be sentient. And so I just had like the craziest thought in the background of like the red-blue shift, and that it's like these energies are like more extreme than ultraviolet and more extreme than infrared, right? So it's like hot and cold, but going out in those other fields, and then there's all the different legends of it, and then the whole red-blue shift, and then it's like, remember the old school plastic glasses of like the red lens and the blue lens, and it's like, what the heck were you actually watching in those old Ghostbuster videos with the red-blue glasses?
Well, I said this before to Jeremiah.
What was that actually doing to your brain?
When I was talking about ghosts, I said that literally what you just about said, Mike, was it's a snapshot in time of a memory that came from somebody or some event that happened that's an emotional, like, scarring event. And that high energy event that came from those two people literally snapshotted itself at that grounding point where they were when that occurred. And when we get thunderstorms, lightning,
Yeah.
Or for that matter, ley lines start
Right.
to align a little bit more. We get a plasma discharge that reactivates that memory, which becomes somewhat like a ghost, but it's not sentient.
It's not our
a
memory though.
plasmatic form
Okay,
of
Not
okay.
our
So
memory.
last year, I accidentally, and I did accidentally do a 10 times hero dose of DMT, and I met the Watchers, the machine elves.
Allegedly,
whatever
accidentally
you-
did 10 hero
yeah, I
doses.
did accidentally, half a gram. So, and they
That's
said,
funny. I never got no effect
they
out of
said
that
that
stuff.
they
I did a little
exist.
bit
They
of
were
it.
on a harmonic triplicus above us.
Mr.
And the thing being that they're born of smokeless fire, all that they're meant to be the jinn, aren't they? The people that
So,
we make
Mr.
DMT,
Ian,
though.
could you use like how they do with 3D scanning? Could you possibly create like a 3D scanner with two input sensors for each, and then like somehow make a 3D standing shape inside like a game engine?
that's smart.
Sorry, my mind was saying that and I had to spit it out.
In what way? I mean, I have a
Like because
workshop with
if you
3D
could put it
printers
in a
at the side of
game
the house,
engine,
and I
that way you can
I
view
print exotic
exactly what the
material,
3D space is going on, and you can fully record the space-time event of like what you're witnessing. Like if you're claiming you're able
there's
to
no way
see
you
these
could. It's not a
ghosts,
case you're
right?
talking about recording. That involves time, and where you go on that experience.
Oh, sorry. I just thought
there
like you
isn't
had
any
like a
time.
recording device that you use.
Yeah,
to
he has.
see
Well,
these
it's sensors though. Right now, it's sensors.
Yeah, there's
but
sensors. Yeah, and I'm saying like, could you not set it up like a 3D scanner or 3D? You know, like when you have a 3D scanner, it has two cameras on it and two
It doesn't need it.
infrareds,
It
and
already
they're able
scans in
to
3D.
get the 3D
Scans in 3D.
shape
You get a
with
3D
like
radar back from it. Okay, so imagine someone gave you the motion tracker from the film Aliens. Working.
So
in your
you're
hands.
talking about like when it throws out that 3D grid, like it's almost like a
and
giant.
it's got the dots coming.
It's almost like a giant serial scanner, like where it sends a serial code where it can wrap around.
but completely real time. But
dolphin
completely
sea
real time,
sort
and
of
with no scanner thing going backwards and
That's
forwards.
got to be freaky
It all
to
happens
be
in real time, but in a very similar cone sort of shape. So we have that at the moment. We have it as a handheld device that runs on 5 volts.
Okay. That's wild. That's
got to be
awesome.
scary to turn it on and just start seeing something in your room and be like, then
Yeah,
what
you do. You do. That's the scary thing. Yeah, and I've recently
so like you're
lost,
seeing
I've
this through the
recently lost
LCD
some
screen,
cats,
right?
and what we've witnessed in the glitches moves about the speed of a cat, because you can see the humans moving.
Oh,
It picks
man,
up humans, so you can see how fast the human normally moves, and these Dopplers or glitches are moving double the speed, and they're leaping.
Imagine
around
you're
the
trying to
place.
sell a house and
You
they
really
come in there
need
with a
to publish
field
this,
meter and they
Seriously, if you can get
Mr. Ian, you any idea how unpopular you're going to be?
They've got the videos, so they can show you the video, and then you'll see what's going on.
Like if you can get somehow.
Can you play one right now?
There's a
Can you
reason.
bring it up and
There's
share?
a reason.
No.
Come on, we're live on all the
There's a
channels.
reason.
Full disclosure.
We know I can't, because we've got an investor, and the investors we're tied down for another couple of months at least.
Give us stateside.
No, there's a reason why it's separate, because it's going to be too upsetting, right? We don't perceive it because it's not available to us, because it just how do you concentrate when you're able to see everything like that going around, right?
Right.
Well, if you could, though, you know,
you're like
what
schizophrenic or
useful
bipolar, right?
It interferes with the survival instinct.
Tear down the walls, and open the
This
doors
is a
because
lesson
you
of
got
teaching you
things
the
in your
moment.
house that you can't see.
Ian, this is teaching you the moment. This is the lesson
Sure.
of this life, is to teach you the
Do you-
moment. So
how
when you
many
go into
people
a
want
place where
that
there's no
moment to be
time,
shared?
at least you've seen it segmented.
Maybe you could use it to get rid
But
of the
this
things
is-
in your house.
This is
Yes,
why.
yeah,
This
sure.
is
When
why.
You doesn't matter.
This
Yeah,
is
we
why our brains organize our lives in a linear manner, even though our brains think higher dimensionally, right? We can access those higher dimensions, but they're organized linearly to keep us alive from an evolutionary standpoint.
Yes, because everything happens all at once. All time happens
Right.
all at once.
If we were experiencing all
100%.
that, it would drive us nuts and we wouldn't be able to survive.
Exactly.
Which is why we vibrate at the rate that we do consciously, so that we don't get overloaded, basically, right? So that we can
Right.
at least run away from the saber-toothed tiger or whatever it is that allows us to experience what we experience. We don't know anything really about it. Mr. Ian, I think
we do.
But we can tap it.
We
Sure.
experience time in the
Having
way we
light
experience
after
it
the
because
sun
of our
goes down
critical
is a big
frame
part
rate
of it.
fusion.
Right.
Your critical frame rate fusion is just defining how you experience the world. So for
Is
birds
that
with a critical
right?
frame rate fusion of say 140, they're experiencing the
And
world
this
quite
is-
slowly compared to us.
Is that the fusion of the sun or the earth, or if there was inside the earth?
What
Critical frame rate.
Critical frame rate fusion is at what point frames blur together to become video.
Right.
So for us,
And I did.
frame rate fusion is about
I
50.
read a very interesting book, and I worked for about 5 years, and I could not do it right. Bill Bankston, who was a healer, he basically worked with a kid that he met at a condo block who was able to create clouds by purely willing them to be there. He explained to him how to create the effects was by increasing your visual acuity for rapid pictures. So what you do is your visual, and that's what you're saying, the visual frame rate. Actually, if you can get pictures of things that you learn in your head and you roll them over very, very fast, you go into a different conscious perception, and things change seemingly for the better for whatever those pictures represent.
Exactly,
because they're
that's a
all loaded as
manifestation
well.
technique. Yes.
It's a kind of a manifestation technique,
If
but it's
that's
also
true.
extremely difficult to do. I mean, I may not be mentally gifted enough to be able to turn out those frame rates out, but I could probably get to about 18 frames per second. Just going at it. And it did.
the image is
Sometimes I
similar?
got a really weird feeling, but I never got it to get it consistent. But I get what you're saying, and that's what he was saying afforded him. And he was a scientist. He was like a professor at a university running these projects with students, and he only ever wanted to try and figure out what was going on. So he encouraged people to try and do it to see what the effect would be to them. But he said people who mastered it never said it was a bad thing. They said it was always extremely beneficial. So that's the video frame rate is very it's how, and I assumed that meant that your brain was being encouraged to,
it's giving your head a wobble.
This frame rate was causing it to vibrate differently, and you were seeing things in a different way, that it was opening up different things. But it wasn't just doing that, it was affording things to come to you that enabled you to pass that energy through if you were trying to heal somebody. I mean, that was the whole purpose.
Would you imagine it would have a hemi syncing effect? You're aware of this, the gateway process, the hemi syncing thing.
I don't know anything about that.
What?
All
the
of these
CIA
things,
paper
these
released in the
Hemisync,
80s.
yes, it's binaural beats Hemisync. It was developed by the Monroe Institute, and it's controlling the brain into putting you into certain brain states and wave states.
No.
And yes, we got to
Called
do a full
Hemisync,
episode on
Ian.
that.
I haven't.
So Ian, promise me that you will Google the CIA
Sorry,
paper
my
on the gateway
apologies.
process.
That was me that wrote that.
CIA paper on the gateway process. So when you pick up your phone to phone your brother or your sister, and the phone goes and it's them on the phone, and you go, "Oh, get off! Don't be stupid! I just literally had the phone in my hand about to phone you." Yeah,
there you go.
That's called the gateway process, and that's not in most humans. It's like a torch, but by a process known as hemisyncing, where you sync both hemispheres of your brain. You can turn it into a laser rather than a torch, and the CIA were training guys up to do remote viewing in the Cold War using it.
Yeah, I do something
So-
like that with Jeremiah.
So
Yeah.
I mean, so it to actually encourage that process between the brain hemispheres, what's it called? The binaural beats, right?
Yes,
Where
it's
you wear headphones,
similar thing. Yes, yes.
and you have
Hemi-syncing.
that beat frequency that forms that your one side of the brain is hearing one frequency, the other is this, and it's completely unusual. So it starts to cause one side to try and match the other, and it
Yes,
tends to
that's
harmonize them
hemi-syncing,
somewhat.
Ian. Yes, hemi-syncing.
Yeah,
Oh,
it's async.
okay.
Yeah.
All right. Okay. That's binaural beats then. That's
No,
Yes,
but it's more than
binaural
that.
beats
No,
and
Ian.
hemi-sync
It's
are
so
one and
much
the
more than
same.
that. Literally,
Correct.
check
I
out
was
the
using
CIA
those
paper.
beats for like a month. It worked.
That was
I didn't need
interesting.
it
I didn't
anymore.
know I didn't know they originated from a CIA program. That's awesome.
Yeah, it's called the Gateway Process, and they were using it
At
for
the
remote
Monroe
viewing.
Institute.
Yeah, it
Yeah.
didn't originate from the
Monroe.
CIA, but the CIA adopted it and made it their own, so to speak.
Wasn't it the strange
That
the
makes
TV
sense, though.
series
That's a
Stranger
crazy
Things?
revelation.
The TV Stranger Things, wasn't that the Montauk? Wasn't that at Montauk?
Untalk Project?
I
It's
thought that was
possible.
at Montauk. I thought the whole hemi-syncing thing in the Gateway Process began at
It was a
Montauk.
part of it. And
Well, they
that
were
was
using it.
Oh, here's
all in
something
the
crazy.
Comments,
Because
but
the
I'm not
TV
sure.
The
series
electric
Stranger
meter.
Things was originally going to be called Montauk, and they changed the name to Stranger Things.
Yeah, that's because people
Yeah, that's right.
want that brought out.
And that was Hal. Was that Hal Bernie? Am I right in thinking that's Hal Putoff?
Well, I think it was higher than Hell Putoff, but I think Hell Putoff was definitely involved.
That's
Well,
crazy.
CIA
Yeah,
were
we see a
crazy.
lot of
He was
these.
heavily
We
involved.
see a lot of these.
He was
Kit
heavily
Green
involved in
ideas.
plasma.
Kit
Hal
Green
Putoff
was
was
a part
heavily
of it.
involved in plasma research as well.
Kit Green was also involved.
Yeah, we see
Yeah,
a lot of
I mean,
these
I
fringe
wonder what
ideas and methods originating from like black magic
Not
programs and stuff.
fringe. It's like interdimensional spirit science that is
Yep.
super suppressed, and it's on all the quote unquote intelligent agency institutions. And
Ian, it's
and then
I
you
don't
get to
think
all
it's
the
so much
occult
interdimensional. I think
writings
it's just a
and
natural.
practices. It's
Well, whatever you want to call
It's
it, you
because
know,
time
it's
is not linear.
it's a pattern, you know.
We live linear on this planet. Time is not linear. That's what it is.
Time already happened.
multiple dimensions of time and fractals.
The
within it.
first cycle of time already did a turn. We are on a repeat. That's got to be
Guys,
too possible
I've got
because
to.
I
how many
disagree.
cycles have happened
I go
by
round in
now? The
circles.
first one must
I go
have
round in
happened already.
circles in this.
I believe our
I go
soul
round
is
in
not
circles on this.
linear.
I wonder.
And if we
what-
pass, we go into nonlinear.
Well, what's the purpose of all this anyway, right? I mean,
Ian,
it's
I've
fun.
put the
It's
link
fun
in the
being
chat.
in time.
Time
It
is
is.
a.
Thanks. But it's fun. It's fun being in time, and it's fun enjoying life. There's obviously a reason why we're here in this form. In this, if everything else is all plasma with massive intelligence, then there's a reason why we're here, as partly, you know.
I like
baryonic
that.
matter
So-
and part plasma,
So,
perhaps, or something like
Nathan,
that. But at the end of
earlier
the day, we're
today-
having fun, but there are things that we need to sort out, right? That's why we're here.
Nathan, earlier today in your video, you were
I think
describing
it's
this
just-
intelligence control aspect, and it's like, is that coming from a plasma field? And it's like
Who is
it's
that guy?
is really parallel to a lot of what I saw and heard in the Keshi groups when they reached these plasma field states that they spoke of.
But the plasma field states created the right way you could attach to it yourself, because essentially we are made of a plasma. You have skin effect all the time.
In
So-
between, in between the ground and the ionosphere is an ionic transducer in essence. Right? It's holding a space charge. It is a standing sound wave, and literally we are in it, and we are it.
Yes. Oh, well, essentially, no, we're the shadow of a fifth dimensional quasi-crystal coming down through an eighth dimensional supercrystal.
The galactic.
Which is interesting. If we're just one pure facet of that crystal, then surely there must be points in our reality where the overarch of that beam from the facet meets with the facet from another crystal, from another aspect of the crystal that will be right next to us as
Interesting.
well.
So wait, you think we're facets of a crystal? Is that what you mean?
A bit by a crystal, I mean a repeating form, and it's repeating form outside of time. So if you imagine if you saw yourself outside of time, you would see yourself from when you were born to when you died as a big long snake going all over, in and out of rooms and up and down stairs, and as your entire, like a knot, yeah, and that would be you as your entirety if you were to see it outside of time.
That's one interpretation. I disagree, but that's one interpretation for sure.
It would have to be, if that was the playback of your entire life, seen as one entire playback.
Who says you only live one life?
Timeline of
Yeah,
your life.
that's the playback strand fractal of that dimension of time.
Yes,
You're both
exactly.
correct.
Well,
But
let's
that's
not
the whole
let's
time.
not exclude
Very well
magnetic
put.
memory and dielectric memory that's imparted on the Earth, as we go through our linear
There is a book.
experience.
There's quite famously a book, isn't there? That oh God, what is the book called? The bloke that wrote Stainless Steel Rat. Can't think of his name. Anyway,
Yeah,
he wrote a book about aliens that came and took aliens, 5-dimensional aliens came to Earth and took a guy away, took him to their planet and stuff, and returned him. And as a result, it was like an extension to the Flatland book, but on the dimension above, essentially.
So there is kind of scientific evidence that plasma crystals can actually form naturally now as well, which is the whole thing that lends towards their supposed inorganic sentience that can actually exist, and intelligence can exist in
Conditions for
plasma
that
fields
exist within the Earth, don't they?
Doesn't Maury
and
King
in the Kordylewski clouds between us and the moon,
And in the sun.
apparently,
Yeah.
yeah, and in the sun, everywhere. Yeah, everywhere. I mean, it's but the crystals can form seemingly theoretically. So yeah, I mean, it opens a lot of possibilities, right?
Well,
I
Maury
mean, it's
King
8
talked
minutes
about
away, but the tendrils from
ionic
the sun
crystals.
certainly meet us. There is a level of control of the sun and connection from the sun to the Earth.
Hey, question for Gerald. I heard something just yesterday. Now, this is specific to geometry.
Yep.
Geometry came first, numbers came second. What do you think?
I would have to agree with that to a sense, yeah. Because we all live through symbology. I mean, our very existence belongs to geometry in many different forms.
You have to
There's
build
no
the library
flower.
before putting the books in.
What's that?
You have to build the library before putting the books in.
Yeah.
Right.
Yeah. Very true.
And the fundamental form is geometric, and the numbers that express it come secondary to the actual pure geometry kind of thing. And I'm wondering if that's got something to do with what you're making.
Perhaps the dream that led me, dreams that led me to make this would say so, by far. And this dream that led me to build this coil and 177 others led me to think that this goes beyond what we understand. There's more than one dimension. From my understanding, there's 24. There's 12 negative and 12 positive. How true is that? I don't know. I guess we'll have to find out in the future, right? Right now, it's just a hypothesis or a theory, even a weak one, but still a theory.
So you're using maths to define that. So I presume you have a dimension 0.
Yes.
Good.
Where there is no time.
Yeah.
And no space.
Yeah.
And
Yeah,
just
there's
pure
certain
light.
antennas that actually follow those laws of hydraulics, analogs. So like, what's his name? Eric Dollard, he found through the Alexanderson antenna that he was able to cancel space and time in order to get a message across the Atlantic instantly. And he did that. He also created the Alexanderson alternator, which was a magnetic flux switching type of accelerator or rotating disc that he had that they use in missiles and stuff. Actually, what's his name talked about it? Maurice
Didn't they
Smith.
call that the devil's device?
And well, in essence, but yeah. So the magnetic flux. All right. Sorry, actually, someone's
Pick
yelling
out
for
Daniel
me.
Nims.
Back in a minute.
You heard of Daniel Nims? This guy, he built a device to see interdimensional beings, and then he disappeared.
And then he disappeared. Yeah.
Yeah, really. Pardon the pun.
Well, he created a bunch of images that look awfully compelling.
Hopefully not a Men in Black.
Right, sorry, guys, I'm back. I had to help my mother or something there. Anyway, so the
just a
I'm
good
explaining
son
is
moment.
that these different antennas, like the one wire antenna, it follows a different analog than a closed loop antenna, and the light follows a different analog as well, right? Like this is shown by Tesla in his magazine articles. Like he explains how the closed loop antenna works different and how the open or the open wire one wire circuit works, and it literally and how his x-rays didn't harm people because his x-rays would act upon you and you'd be the capacitor and it bounced right back into the system and into its ground, instead of a closed loop system which the analog of the light would follow, hit you, ground through the ground and into the ground and back into the system that's hitting you.
The closed loop, back into the closed loop.
And he explained that the one wire, like the one wire light, would give off cold neutrinos, or well, that's what we call them today, faster than light type sources. And the Alexanderson system was capable of doing both. So like he shows, Eric Dollar shows that with the one wire antenna, it's capable of beaming energy right through the ionosphere and into space. Whereas closed loop antennas, they hit the ionosphere and circulate back down into the ground and back into the system of the antenna.
Yeah, because a closed loop antenna is basically a ring.
Yeah, and the Alexanderson system was capable of doing both, shooting into space and looping.
And the thing about the ring, though, is it's an omnidirectional signal. That's why.
Well, it looked like a ring. It looked like a toroid with a beam coming out of it. But anyways, so what he explained though is that when they used the proper amount of capacitance and proper amount of coils, they canceled each other out. So like you'd have capacitors and shunt capacitors and everything to make the system cancel all the time and space out of it and then transmit. Right. So like I keep telling all you guys, like you guys are all following closed loop systems. Open your mind a bit, get a one wire system, learn about it. Like I have books from the 1800s that just blow your mind because you wouldn't believe that all this stuff, like we're reinventing the wheel.
You mean no negative, just a positive.
Because we don't really understand that there's electrostatic systems, magnetodielectric systems. This is from an 1830s book.
Yeah, Taryn, you're working with
electromagnetic
systems. A book related to
pyroelectrics, and we have a bunch of other stuff. And this is 1830s before the Civil War. Sorry, Barry, I didn't mean to cut you off.
Is it NIMSA related, that book by chance?
No, it is literally a book that was given out to students in the 1800s. They have student books and they have older books. And I'm telling you, we had so much electrostatic, magnetodielectric, electromagnetic technologies in the 1830s.
Yeah, they crushed it. They crushed it.
I keep saying all the time in the chat, to the warriors goes all the glory. But
that's
the
just
engineers,
applying a positive
society.
potential, a one wire positive.
Yeah, but so like JP Morgan stamped on that. stamped
Yeah,
on that. 'Cause
well,
that's,
yeah, but he
that's how
understood when
electricity
one
was
person-
Yeah,
standardized. isn't it?
he wanted the positive to return back to his piggy bank through a negative.
Yeah,
Yeah,
well,
but that
no,
became the standard model, so that's
The
what
negative
became
brings
the
it back to the grid.
well, the fancy thing with
neutral.
Tesla's, like a lot of people don't realize, is that like Nikola Tesla was creating like similar to what Bonson and Thomas Townsend Brown were doing. They're creating a little vacuum on the surface of the Wardenclyffe Tower, and this created like a light. So this beam of light could beam to the ionosphere and beyond, because it was the one wire at the time.
What?
Yeah, okay, like
And
most
then-
kids at
then
school,
it's
the
like-
most that
it's-
kids would
that's
see at school was
actually
the
like
You know, there's
image with
a
so many
downside to everything. You
Teslas
can't
image.
recycle a one wire system, can you?
And then he used the ground to transmit the energy through SWIR, which is like where you use really high vibration instead of high frequency vibration instead of a low frequency, and then you send it right through really high voltage, send it right through to another location and up. And like they do this in a lot of
You're
places.
saying just keep using it, don't
Use
recycle it.
electromagnetic-
keep sending it
This
somewhere
right
else.
here is what they'd be doing with the neutrino detector in Alaska and everything that Eric
never-
Hecker has been
right.
saying and claiming, correct?
Sorry?
This would be relating to the neutrino detector array thing.
Yeah,
and
you would have to use a
That's
one
our-
wire circuit. And what you would do cleverly would be is you would use a cathode ray tube type system and a cathode ray tube recorder and built into one. And because what would happen is it would act as capacitance. So when it goes up, it goes positive one way, then the negative circuit will come back down. So, and if you go through, like, I have a real old book on the Google Drive that I shared with a bunch of guys, and Nikola Tesla stuff. I show like there's a book written by someone, but he wrote it for Nikola Tesla. Like they say he didn't write a book. He actually sat there and wrote it with him, and he went through all his old stuff and explained how the one wire circuit works and the analog of it all. And it's really fascinating. Like he even explained how to improve.
It has to
upon
be
the-
pulses. You can't just send, constant. It has to be AC one wire or something like that.
Well, he's actually in the thing. He talked about pulse DC being better.
You could do. You have to pulse the one wire either DC. You can't just give it DC to a one wire and expect that to be.
Yeah,
efficient.
well, of course, everything.
You're gonna lose all your power.
You're going to get a signal out.
You're gonna lose all your power. You got to pulse it, and then the signal won't even transmit because there's no pulse. Right.
Well, here's even more fascinating stuff is that when Nikola Tesla did his little thing, he made a one wire circuit that matches his one wire coil system where he was transmitting energy, and then he put a vacuum tube on top of it, which made it into a light bulb. And then when he did that, he put a coil out somewhere else, and that beam from that light bulb source beamed directly only to the coil from away,
that's interesting.
instead
I
of
didn't know that.
illuminating light radiantly all the way out.
It was magnetically or whatever. They
that's
were both
how-
tuned, so
that's-
there was
so
a
what he
there was a
was-
streamline of
Yeah. But what he was doing,
vortex
what he was doing
field or
though, was he
whatever.
was creating a circuit. So like when he could be from that light beam, he could create a circuit that would pass back and forth and act as a ground. So he could have whatever is flying could fly around on the energy that was provided to it by, like the
If the two
big
transmitting coils
generators that are
tuned,
pumping
so
power
they're
into
in
it.
tune. Yeah, you can do that.
Yeah, so like so then that way that's what he was explaining with his flying machine. If you see it in the Electrical Experimenters magazine, actually that I have stuff from there that was in 1915 that was talking about flying saucers on Mars. Like they were just stories, but I mean like they were flying saucers. Like they're talking about this. They're talking about field propulsion. Like
in the 1800s.
In the 1915, my bad. 1915, but I mean 1915 though. Everyone says the 50s. Everyone says, all this and that. No, 1915 They're talking about it as if they knew something.
They definitely
way before
did.
Roswell.
Like I have all of it clipped. Actually, I got to send some of it to Nathan so he can show it off. And,
I mean, if they're using the one wire positive to pulse and signal out,
no, well,
power,
it's all about the field antennas. So, like, it's really neat because you could use the Alexanderson system because what happens is energy is distributed differently. So you can literally transmit. So, if you ever see one of Eric Dollard's videos on on Hertzian currents, impulse currents, and instantaneous waves. He grabs a rope and he waves it up and down. Then he does the impulse like a snap. But then when he wants to do instantaneous action at a distance, he tells the guy to pull the rope taut, and then he pulls it, and then he pull back and forth. And there's they're explaining the really cool is that Eric Dollard actually shows you the two antennas. So he shows the Hertz antenna being a positive at the top of the one antenna and a negative on the bottom. Then say there's another antenna, yards away or whatever. It has a negative on the top and a positive on the bottom. Then he shows Nikola Tesla's impulse waves where positives on the top and negatives on the bottom, and negatives on the bottom and positive on top. So it's the exact same, right? Just positive on top on both, and positive on negative or on the bottom.
No, so you're saying he created two identical antennas, and one was inverted on the other end.
Yeah, but what Alexanderson did was that he put two positives on one side and two negatives on the other, and then he would switch that signal. So it literally went from one spot to the other spot instantaneously. Well, from the signal switch. So as soon as you switch that switch, it was practically instant.
Well, yeah, if they're in tune and they're already linked up through a carrier wave, then the data in that carrier wave will move instantaneously.
You got to go, if you have access to my, I'm going to have to give access to Google Drive to a bunch of people.
The carrier wave is already there if they're in tune. You don't really need a lot of power to establish that,
Well, I think I sent something to Nathan about the field antenna video from the 1940s from the United States Air Force.
Two locations.
But that was really epic.
Perfectly tuned to each other. Tesla could do that,
yes, they'd be perfectly. Well, you have to look at the field antenna setup. Like I said, there's capacitors and there's coils that are canceling each other out. In a sense, you have to look at the antenna and realize what he's doing, and he explains it in high detail. Like it's very simple. He simplified it so much, like it's almost amateur, and like it's in his Borderlands stuff.
He's trying to put them in phase. The two transmitters, he's keeping them in phase.
Well, if you look up the Borderlands stuff for Eric Dollard on the Alexanderson antenna, you might find it will be the patent of Alexanderson's field antenna, and at the bottom he shows all what he figured out, and it is like honestly the most epic thing I've ever gone through because it clarified everything to me. It made me understand why it is instantaneous. It's all about field antenna and circuits being open or closed, and how to have closed circuits with open circuits, like which Tesla already teaches everyone. We literally learned it all through time. But what happened is that when the Alexanderson system came out, the United States military adopted Hertzian system right away because I believe they knew that they were able to do field antenna propulsion.
Is electrostatic a pulse or static pulse, or is it something else?
Well, I believe that they were sending everything. Like once they figured out that they can make flying radios in a sense.
I don't see how you could charge something up to a high voltage and not establish some kind of a frequency through that pressure. Because,
I've never seen you
at a low voltage, you're probably not going to get a.
Well, you got to go through his antenna to understand the electrical systems they were using at the time.
They were using high voltage Van de Graaff generators, probably.
No, he built his own Alexanderson alternator. If you go through Eric Dollar's stuff, you would know that. But what happens is it's literally a magnetohydrodynamic flux switching type of alternator that is really, really well done. Like like I said, they use them in missiles and stuff because they can easily turn them into like Tesla turbine fans. And then if they have to, they could put like wave cutters inside of it, and that way, which are just like plates with the opposite shapes, so that when the turbine makes a motion, it creates an open and close. That way, like any cavitation that's charged can be taken and ripped out of the circuit and then used as energy and electrical energy. Oh, yeah, perfect. Thank you. So scroll down.
There you go. That's it.
Yeah, scroll down.
What does baffled mean?
Maybe some specialized materials can
keep
oscillate at low
Genius,
voltage.
though, isn't it?
Yeah,
Really?
keep scrolling down. I will show you just because it's at the bottom. It's past all this, where Eric Dollard actually puts his stuff. Who's showing this off? Oh wait, go up. I'm just going to make sure what that is. Up higher. One more.
Did you add me to the Google Drive, by the way?
What's that?
Did you add?
No, I haven't gotten you the link yet. No, I've been jabbering.
Okay. Yeah. Okay. No worries.
Don't worry, you'll have it. I'll make sure you will.
Can you get me on? You're on the server. You can get me on Discord, can't you?
I'll be on there soon enough.
Yes. Yeah. Just
I'll
be in
definitely have to
general
get
or
that.
something.
All right, so keep going down. This is yeah, you guys can blame Canada for this. Anyways, keep going down.
Always blame Canada.
Everything's gone wrong.
That looks like a particle accelerator.
Yeah, it is quite fascinating, isn't it? Keep going down.
Mm-hmm.
Well, because it's all field antenna stuff, anyways, for particle accelerators. Oh, go back up.
Right.
Yeah, to that right there. So this is the simplified stuff. So he shows you how the Hertzian antenna works. This is the basic Hertzian antenna. Then he shows how Tesla's antenna works, right? Now go down. So he shows you how Marconi did. Oh, no, keep going. I'm sorry, the next page. It's my bad. No, back up one more.
Taran, you know that I've given the ability to, the AI on the exotic propulsion server. Me and Jeremiah wrote the AI, and we've given it document handling ability, so you could upload this PDF to it, and it would.
Yeah, I'll have it up. I'll put everything in proper order. That way, it actually gets done right. All right, so if you go up here, you see like he shows the Tesla circuit, then he shows the derivative there, and then that's the Marconi one that's right here. So all Marconi did was when he first did it, he threw an antenna on top of Tesla's system. That's why Tesla was able to sue him. Underneath it shows the Alexanderson system, which shows that he's literally canceling space and time with this type of system. Actually, if you go down, it's even more accurate. So you can go down now. Now here, this shows the electrostatic field and the magnetic field working together. Go down. Yeah, that's good to know, but not really what we're looking for. The meat and potatoes we're looking for. All right, so here it shows you that the Tesla system goes straight through the ionosphere into space. Underneath shows the Hertzian system that literally hits the ionosphere and circulates down back in through the ground and back into the terminal. This is what all closed loop circuits do. So, and that's what all one wire open circuits do, which Tesla was trying to teach. So like there's a big war through alternate current and direct current, but the real war was open circuits and closed circuits.
Open versus closed. I wonder why.
Well, that was what was hidden from the general public because they wanted to hide that because there's a lot of secrets there. But anyways, go down. So yeah, so this is showing you where the difference between Marconi system and Tesla system. Tesla system was grounded at the direct center, and whereas Marconi system was directed at the very bottom of the ground. As you know, we don't do that. We follow the Marconi system because that's our circuit that we were taught to follow. All right, go down and get a bit more.
Because it's a standard model, though, and we live in a standardized world, so it's
yes, Marconi standard.
Well, the government is governance, so they governance our ability to stay on Earth and become surface dwellers, I believe.
Well, yeah, but standardization is a part of that because we live in modular housing, don't you? If you go to buy a plug socket, it has to be able to fit the existing hole and screw fittings and everything as the old one did. So standardization across the board, including the electricity supply like that. So
And
Marconi
the
was
difference
the system they
between Europe,
adopted, but
Asia's,
arguably
and
which was correct.
America's.
Electrocuting elephants, weren't they?
Yeah. So sorry, I had to say something there. All right. So, anyways, so if you go down a bit more, because this will show you the difference. Okay. So can you flip that? Any chance you can rotate? I can't, but I don't think you can because I know it's Google Drive. It's horrible. No, you can't. Okay. So scroll down a bit more. Well, this essence is teaching you that the ground. If you go back up, actually again. So this is what's using like the SWIR antenna with the up air field antenna. And what's happening is that he's doing both the circulating within the ionosphere and launching into space. This is the Alexander system, by the way. But he had to use the field antenna that was given to him at the place when he was doing his project, his first project of transmitting messages across the Atlantic. Eric Dollard explains this. Really, really, if you guys ever get the time, check out Eric Dollard. I'm sure, a lot of these guys know that. That's the golden rule. But anyway, scroll down. Scroll down more. Okay, I don't know if that's the stuff or not. I don't know if it's. I don't have my notes on there or not. But he's explaining here where he has the capacitors and shunt capacitors to cancel out both time and space. I wish I had my notes up here because it was just a sketch of Eric Dollard's notes on one of his videos, but he explains it in far more detail about how Alexanderson, because later on so Alexanderson's system was kind of a little incomplete, whereas Eric Dollard completed it. All right, keep going down. I think actually that might be it for this document, but scroll down real quick so I can skim it, like data. Okay, keep going. That's it. All right. So, yeah, that's it. All right. I don't know if that actually, we should keep going down. Just out of curiosity. So you might actually show the analog where where I explain the antennas, how the Hertz antenna was, opposite fields, and then the Tesla was the same field, and then the
Hertz antennas were for radio, not power though, huh?
Well, short range radio. Whereas these antennas were designed for electrical energy transmission with the
radio frequency.
But the thing is that the Alexanderson system. So yeah, there's better pictures of this in the Electrical Experimenters magazine. I do have that set aside. I've clipped everything for you guys. Like I mean it. Like when I did this drive for you guys, I mean I have
radio
everything
frequency is megahertz,
Well, yeah, but we're talking. There's difference between radio frequency and then there's difference between electrostatic.
Well, I'm just saying 60 hertz is very low frequency. It's not in the high frequency.
It can be whatever you want if you design.
Well, the grid uses 60 hertz, so that's
you engineer the antenna. Like we don't have to follow the systems that are in place. We can create our own.
We use a low frequency to transmit power on the grid. It's 60 hertz.
Balance it. But anyways, so yes. Oh darn! I wish my computer wasn't lagging because I would show you guys everything I need to show you. I swear it's the cronies.
You got to enter it into AI, and it will make it all beautiful, organized, and.
Well, thanks for that info, Ben.
Right? I think AI is the key of organizing all of this information.
No, well, AI needs to be guided. It needs to be. Like, if I could just take the drive,
we can train one up
lay it out properly. Not only that, historically, so that the AI can learn through history that, okay, these changes were made. So this is what this means. And this is what that means.
Well,
And then,
dude, talk to me. I'll write you a custom AI to do the job for you. Okay? Talk to me
right,
after the show.
all right. All right. So,
Walk through
Bernie,
right
make sure you send me his email.
Absolutely. Well,
Yeah.
I don't even know if I have Eon's email. I have
We need to
come
get
on
you-
Twitter.
So,
We
so
need to
like,
get-
I'll send him
Hold on, I
yours.
can stick it in chat. Hold on.
yeah,
private
so
chat,
like there's different cool stuff. Like there's these antennas that show up, like like where this guy's extracting a whole bunch of like just millions of volts of power through like a triangle grid. And he explains, like through the one book I showed you guys earlier, that you could legitimately tap energy with a spark gap into like any type of machine, and you could literally extract this energy. And like, I mean, it's useful energy, and it's all came out from this guy saying that literally he just took this book and made this. And I showed it to you guys over before. It was from Frank Peak. Hold on, let me look for his book because I just had it out. All right, it's Frank Peak. Darn, of course, I can't find my spaceship book or my other book. All right, forget that. Anyways, so the guy who got me into field antennas and understanding this field antenna stuff is Leek Mirbeau, and Leek Mirbeau ran the Troy School in where was it? New York. Yeah, so it's New York, Troy, New York, I believe. And he claimed that, like, I believe this is the secret school, and he claimed that the field antennas are the most important part of it because you can do what's called, so his field antennas were superconducting niobium titanium rings that he created wraps of carbon fiber, I believe, that he wrapped around it and then solidified it, so that, because what happens is when you hit power to it, these wires want to centrifugally force throw themselves right out, and then they'll snap. So you need to really hold them together. And so that's what he used. And what he did with these, like with this, he was able to do what's called geomagnetic torquing. And I guess the Earth has, I believe it was 2.5 Gauss. I'm trying to find the book. Oh, I found both of them. Actually, I found both of them right on. So, all right. I'll just flip to the geomagnetic torquing. He has equations and everything, but it was so like there's an area of. Oh, where'd it go? Come on, I knew where it was. Oh darn. All right, so actually, first of all, I'll just give this. Geomagnetic torquing. It took about 200, I believe it was 200 amps. I have to go.
2.5 Gauss is not much.
Look right now. No, because he was able to
2.5 Gauss
transmit
everywhere. It's like evenly spread 2.5 Gauss.
Well, that's what he claimed.
A huge magnet, but a very low magnetic field.
Yeah, well, he said it was 2.5 Gauss, and he said that by changing, like there was 2 million amps on the bottom and 4 million amps on the top coil.
Million
and he
amps.
he had to use a Lorentz force, because the Lorentz force would stabilize the craft, or the craft would tilt on an angle from the center of the Earth to the ionosphere. So that could literally tell you exactly where you were on Earth, but that's really not handy. So you would want to straighten your craft out by creating a Lorentz force where you have 2 repulsing coils that will just level yourself to the Earth.
2 coils presenting alike fields at each other.
So who was the guy that showed off the drive?
That was Shawn.
That was Shawn? No, my Google Drive there. That he had the access to the.
Nathan, I think, or Ben.
Yeah, I was on there. What did you need?
Oh, all right, so go to MHD.
Okay, hang on 1 second. Let me.
Magnetohydrodynamics.
Magnetohydrodynamics.
Okay, hold on.
These are all centrifugal concepts, man. Even
Well, yes, there's centrifugal and there's impulse.
EHD.
Yeah, EHD, MHD.
impulse,
Sorry.
Okay,
impulse
then
would be the DC pulse, and AC
Yeah, and
is
then
an
go to
oscillation.
go to Mirabo.
Mirabelle.
MYBRO.
Okay, give me 1 second. Oh, let's see.
MY
I got Stan Myers.
MY
Give me.
RABO. My bad.
But you see, nature creates AC very easily, and it also creates
No.
DC pulses.
No. What it does is that it's spinning, and all the dielectric particles that are in the air are creating friction, which creates electrostatic charge, and because it's turning, it's creating a magnetic field.
What I meant to say, it's an analog signal, which is very similar to AC. It's just, I shouldn't have said AC, an analog signal. Nature creates an analog signal, but it also creates a digital pulse, a pulse signal under pressure.
Nathan, did you get to the Mirabo folder?
No, I'm not finding it.
So it's an magnetohydrodynamic folder,
you know,
MHD.
Snap.
Yeah, I went into MHD. I got a lot of folders.
And then you scroll down to MYBRO, like the in big letters.
I got MEYER, Stanmeyer. I don't have anything after that. I also have Marks, so we must be in the wrong one or something.
Whoa! Hopefully they get deleted. Oh darn! I want to skim on my drive, but I'll start lagging.
All those seismic readings are analog signals. They are very much like an AC wave, you know.
Yeah. All right. So I'll look it up myself here. I'm just going to quickly skim it. Oh, of course, it's not going to give me it. Hold on.
Whenever you see a spike,
it's
an earthquake.
All right. Drive.google.com. All right. So I'll go to the image. My drives. Sorry for speaking out loud. So yeah, all right. So, I'm sorry. When I say all those amps, I'm talking about all those amps and 400. 400. I believe it was 400 meter or 400 foot ring. I'm talking about on the loop of the antenna itself. There it is. I found it. Okay.
400.
Yeah, because they're superconductive rings. So let me go in here and figure out what I can do here. To explain this to you. I'm gonna have. Oh darn! My dog's old. She's like 15. I got to run her outside soon too. So I got to skim through this real quick to get this across.
Dog dude, understandable. Appreciate this.
I got to carry her up the steps and stuff too. She's 90 pounds. Poor bugger.
Oh.
Okay, so all right, so MYRABO. Can you? It's there. It's the MHD slipstream accelerator. Sounds like something off Star Trek. You see that?
Accelerator.
OldMan builds.
Yeah, hang on.
That's the shear torsion shear that the Canlis was talking about.
We're in. Oh Jesus!
Is that what that is?
Give me 1 second. Okay. We're in EHD, right? Electrohydrodynamic.
MHD.
MHD?
Yeah, that wrong folder, dude.
MHD. Okay, well, that's probably what it is. Okay, now what's the next one? Mirror?
Mirror. MYRABO. Yeah, because this is mostly magnetohydrodynamic systems. I'll be showing you electrostatics though, because it's in here.
MEYER Rudolph. I got MHD.
MYRABO. MY.
Got it. Okay, now which one? Just any of them?
1985 one. Starts with 1985. It's a NASA document. Yeah. Now I'm going to show you guys the NASA document of flying saucers that they don't say exist.
On the year that I was born, apparently.
No, 1983, my friend.
85. Okay.
Oh, it's 85 was released. 83. It was unclassified in 85. 83 is when he made it. Ooh, TR. What if that's Telluride?
This one?
Okay. So if you in this document, you might as well just skim through it because it's gonna blow your mind. I'll have to be right back though. I have to put my dog outside. Just skim through this, and it's full of goods. The best stuff's at the end because then you get to see all the space cylinders, the O'Neill cylinders, and how they plan to use free electron lasers to beam energy back to Earth and make these craft fly as an assist. Like I'm telling you, they had all this. Like when I show you the 50s stuff and the 70s stuff, you're gonna just like the movies, the videos. You're gonna be just like, oh my god, this is what they have. They just lied to us.
It's stuff like this that really puts the David Wilcox of the world to shame, doesn't it?
Oh, that's what it's supposed. Like, you know what? They're all about, literally, they're all about pickled aliens.
Really, this is where it's at.
When realistically, it's what we have. You know what I mean? It's all about like what can we make? What can we do? What can we overcome? But this
yes, but I mean, this is the real science of it, isn't it? We're not
I know it's the engineering. It's not science. Science can be theory. This is engineering fact.
Right, science.
Yeah, exactly. Theory. Yeah, this is the balls of the situation.
Yeah, it's just like you take
the only thing in science that is not theory.
I can make an electrostatic system that does what you're talking about. This is instantaneous action
and language.
Yes.
Like it's just like it's you got to start slapping shit with engineering because that's the only way you can make these scientific concepts.
Yeah.
A thing by engineering it. Yeah, there's anyways, I gotta be right back. I gotta put my dog outside. I'll be right back.
I think
so I didn't mention, guys, when I did my introduction, I'm part of the Truth Seekers team on YouTube. We bust grifters and con men in the sort of UFO and paranormal world. And
really?
and this is not grifting. This is the hard sort of the hard facts of it, isn't it? Really.
There's guys out there grifting UFOs.
Okay.
I find that hard to believe. It's not something you can grift. Either you got it going on or not.
Oh my God! I mean, there are guys out there making 20 grand in a weekend from a convention.
Wow.
And then there's
Must
us.
be a lot of people that like really wanting to hop on one of those things or something. I don't know. I guess I'm not one of them. A lot of people must want to jump on a UFO, I guess. I don't know.
Oh dear.
I would never get on a rocket and go to the moon or do whatever these astronauts do.
Well, funnily enough, you're really well evolved to live on this planet.
Yeah, I feel the same way. I mean, why take all the risk? Leaving the surface so far from the surface, that's like, don't expect to come back if you start doing that. You might as well just keep going because coming back is even riskier. Yeah, I mean,
isn't it? Yeah, isn't it?
Yeah. You're flying a plane, helicopter, that's fine, but going up into the atmosphere and going out into space, and that's
just in a hurry to leave. Here's a weird concept. So when we're sat in this, we think about the Fermi paradox, for instance, and how we don't contact other aliens and stuff because we're on this tiny little speck.
I keep forgetting what that means.
On one of the spiral arms of this galaxy, and this galaxy is then one of loads in a universe. Okay, and we sort of do this outside, sort of inside out look at it. Okay. And think that there must be other things out there. What if there isn't? What if we're hidden? What if the universe, in order to find human beings, you, I believe, need 6 vectors, and including a time vector as well, which is essentially almost.
Yeah, no, we're definitely hidden. We're definitely hidden, but not intentionally. We're hidden.
Yeah,
by
but that's almost. What if that was the case? Because if you look at it from outside in rather than inside out.
I can prove it to you.
We are unfindable in that cloud of dust.
I can prove it to you with a few words that we are definitely hidden in the universe or whatever, ever go into the forest? There you go. I just proved it to you.
Well,
It's
yes,
very
but
easy
what
to
if
hide
that's its
yourself in the
purpose? What
forest.
if
You can
that is
easily
its
hide
purpose?
yourself
What if
in the
we are?
forest.
What if we are hidden in a cloud of dust, essentially? You know.
Well, look how
What
easy
if,
it is to
what if
hide
the
yourself
purpose
out
for
in the
us
wild.
being here is purely just to enjoy ourselves, dance and increase the experience for the consciousness that's experiencing it through us as vehicles? I mean, if we are the pinnacle of biology, the substrate of biology is chemistry. In order for biology to exist, you must have chemistry, and then the substrate of chemistry is physics, because in order for chemistry to happen, you must follow physical laws. So, and then we look under physics at a quantum level, and we can see that consciousness lies there. So we then as anthropomorphizing humans perceive that necessarily that we are the pinnacle of biology, so consciousness must spring from us, and how could it possibly loop back round underneath physics in some way? Well, what if it's the case that is the substrate of our reality, is this consciousness, and that everything is experiencing consciousness to some degree? I mean, if you have pets, for instance, of your own, if you have a dog or a cat, you're well aware of the level of consciousness that they're experiencing the world in. You can kind of empathize and see it through their eyes to a degree, you know.
Totally.
But I don't think that consciousness stems from us. I think
They just
a
have a
part of the
different
gateway
filter.
No, it
process that
doesn't.
we're all
There's the
linked in some
energy
way. The dream time, the
formations that
dreaming,
are
whatever.
predating, time. There's energy formations that predate time.
Exactly.
They
So
created
the consciousness
being
could well be that crystalline entity, that repeating form, and we are just facets of that form.
It's a geometry of energy that forms all the life you see, and it predates time too. I think because it seems to keep creating life within the time spectrum. It's using time to create life. The preformed entity geometries I'm talking about. What was his name? David Nims, this guy that built this equipment to take the pictures of interdimensional entities. Well,
yes,
they're not entities. They're not like they're not individual entities. They're a single entity that reproduces a life form in that geometry over and over again.
Yes.
Whether it be the elephant, the bird, or whatever it is,
So this is all free electron laser type technologies, but the better one is the circular loop one, which is coming up. It's more like I call it electrostatic CRT television technology.
Formations.
So if you doped the metal with phosphorus, you could make a nice little TV screen all over it, as long as it had a vacuum across it.
Interesting.
Yeah, I think that's all. I think that's why these saucers go invisible. Oh yeah, there we go. Now we're starting to get the meat and potatoes. Look at that sucker.
I thought that it was a lensing of light around the thing from the magnetic field that caused them to disappear.
Well,
they could just oscillate at a frequency that we can't see yet.
Maybe we'll see.
Oh, that yes, just to raise the frequency.
There's a possibility you could push this into space
or lower it,
or sorry,
you can lower it.
There's the way that it's been described. It's been described when you see these craft from underneath. You can actually see them from underneath.
No, what you do is you just beam it into. What you do is you create a vacuum and then you just put it into counter space.
Yeah, but there is an aspect, there is an angle at which they can still be seen because apparently it's a donut field. It's not a spherical field. So
no, the donut field is just the lines of force. That's it literally. Well, it isn't. Sorry, the donut field is the magnetic field, but the donut field with the spoke field is so the dielectric field or the electrostatic field and the magnetic field together create lines of force.
That would be the light
motion, right?
They pop out. Yeah.
What you just said, I think, is the key to understanding all of the Sonora Aero Club, the NIMS drawing.
No. What they did, what was fascinating with them is what they did was they created cavitation in order to create condensed fuel. And then by creating the condensed fuel, they were able to create coherent fuel matter that was able to surround the craft or create lift.
Really?
Okay, right. Refeeding the pressure.
Yeah, but
Just
you're
by
feeding
having
it with
current flow, you
coherent
can create a
matter
magnetic.
or coherent fuel. My bad.
That's
The current
interesting.
flow through the
There's some
wire
meat
is what
potatoes.
creates magnetic.
So are these what they call Rayleigh waves when you have the combination of longitudinal waves and transverse waves? So you've got the
If
magnetic
you're talking about the
donut,
Alexander
and you
system,
have
or are you talking about the Alexander
because
system?
no, I'm just talking about what are called Rayleigh waves, which are the combination of longitudinal and transverse waves. But that's what I was trying to do with the acoustics. I was trying to resonate the coils with their electromagnetic resonance and then match that by tuning it to the natural acoustic.
So what you're
Yes,
skimming
I
by
would
right
imagine,
there.
I would
Coil.
imagine
So
the
I was
American
basically
Navy aren't
no, this is
appreciating
important.
you sharing this at the moment.
This is
by the way.
really important. This is the most important document you'll actually. This part, the most important part of the document you'll find. So scroll back up.
The nuclear submarines use this, don't they?
If you want to call them that, I call them Aeroastro marine vehicles. All right.
Okay,
So
yeah.
they're creating Alvin waves. This is an Alvin wave creator and rider. That's what the cylinders are. So if you go up a bit higher, more.
Back up to
I
this.
think it's more. Anyway, yeah, right there. So
There
this
you are.
explains how the Alvin Wave Rider works with these. So actually, if you do go, like later on when you go down, you'll actually find a picture, and there's a
Alvin Wave Rider.
I think the alien scientist even had it on one of his screenshots for one of his videos, and it's like identical to the shape of what was shown on. Like it looked like it was laying on a like a submarine on a platform on Earth. Like, you know what I mean? Like it was looked like it was sitting right on the dock or
Elvin or Alvin?
Yes,
ELF? Elvin wave?
Wow.
Yeah. So yeah. Anyways, yeah, these are showing the Alvin waves. Yeah, keep going down. There's more, lots more. Like wait until you guys get into the space stuff where they show you how they work the tractor beam system.
I love that this is like the engineering facts of it as well.
Yeah, I'm done with theory tales. I'm so done with theory tales.
When you use low frequencies, you tap into a much slower heartbeat that exists in the universe.
So this is how it's getting its lift right there. It's doing the detonation lift, right, of the Alvin wave type effect.
That heartbeat could be who knows where, but you are tapping into it if you match that frequency here.
Yeah, scroll down.
Listen, guys, I've put the links in our chat there for the relevant servers. Please get on Discord and join them. Come and have a go. Come and chat.
Trying to match that frequency is not easy though, especially with low frequency. It gets harder and harder.
Yeah. So so keep going down. Keep going down. Yeah, we're gonna get to I want to get to the electrostatic stuff because that's all right. Actually, this one's a good one. This is the submarine article, and I actually have the defense one. It's on their defense server. I forget what's called, defense something DCIS or something like that server. I can't remember what it is. But anyways, they show this. I have the document on the drive as well. Scroll down. More. Oh yeah, and keep going down. Okay, yeah, that's just showing the mirror part. Keep going down. So create its own wave detonation for flight. There, right there. See that one right there? I swear to God, there's a picture of this thing black sitting on a it's on a cylinder. It's more of like an oval shape, right? And it's sitting on like a dry dock. And someone has a picture of that, and I swear that is it right there. Like
Where
that
has
is.
that been put?
I believe they reverse engineered this whole document. I believe that's why it was classified. Because usually when they classify it, they go and make it, and then when they're done, they just release it. Because we made it already, kind of thing. Yeah, this is a better picture of the Alvin wave. All right, keep going now. Keep going down. Oh yeah, I guess you don't have to really. There's a lot of good
When
stuff
they
there.
come-
We're
when
skimming,
they
but
come
I want to get to the real good stuff. The electrostatic propulsion, like this. That's the
When
meat
they-
and potatoes.
So there was an advert in the UK for the Royal Navy, and it was one of
Going
the
to-
guys that had come back from working on submarines, and
Oh.
he was saying, "I've got to work in places that I've never been with technology that doesn't exist." And that was part of the recruitment line. So that
Yeah, so like
basically,
it's showing there, like
come and join the Navy and you'll get to see the future shit.
you get to see time's not linear, boys. Anyways, scroll down. All right, so this is just that. Some of these pictures just showing like that they're just beaming energy down to these other craft for flights. I wonder what page are you on right now?
I don't know. I can't
Scroll
tell.
over, just there it is, right there. It's down further. Okay, keep going. I think it's down further because the electrostatic propulsion. I could show you exactly where the free electron energy ring is and how these craft actually work properly. You might have gone past it. I when I was gone. I don't know. Just keep going though.
So you want this ordered? Just chuck me this PDF and I'll run it through Indigo.
Oh yeah, no problem, dude.
She'll
No
completely
problem.
summarize
I'll
it.
get you all the real meat and potatoes. Like I even they even have like Mirabel actually designed. There it is. This is it. Okay. All right, boys. This is how it works. So think about this. The craft is beaming energy and it's hitting the ground. So this is space charge type technologies. This is all pure electrostatic. So you're going to beam a negative on the bottom, or was that positive on the bottom? Positive and negative by the looks of it, because the bottom's ground, and the top's a negative cloud, and you're literally floating around, right? So like they say to hit a cloud because the cloud's full of them, and you could change the space charge within a cloud, which is in patents for the first cloud seeding technology, which I have on the drive as well, because I cross my T's and dot my lowercase J's.
Is that an antenna array you're looking at here?
No, we're looking at a flying cylinder, a 1 kilometer cylinder. 1 kilometer cylinder.
1 kilometer.
1 kilometer cylinder.
At the top?
Flying submarine.
Or is it the round lines?
Aeroastromarine vehicle.
Aeroastromarine, my bad.
Got to cover all ground, right? Anyways, go down a bit more because there's more meat and potatoes. Okay. Oh, the most important part, you guys.
It's so funny. People have been
most
saying that.
important part. So, when this beam from the accelerator ship blasts out, right? It creates an electron beam. This creates a Bremsstrahlung cone. So, synchrotron light creates Bremsstrahlung radiation, which creates positron and electron separation, which reconnects and creates positronium.
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 Wow. Is that how they make the antimatter with?
Heard that with Walter Russell as one of like the hydrogen isotopes.
All right, hold on. I gotta pause this for a second. I gotta get my dog.
Positronium.
What do they do with the positronium? They make an antimatter. What is that, like a triple positron or proton?
That's a positronium.
I mean, is that more than one proton bonded together?
Well, if you look it up on YouTube and I'll show you, but this is more important. Hold on a second. I just gotta. All right, never mind. My dog's got it. Okay. I needed a drink of water. Okay, so what happens is they're going to beam this microwave energy, and the microwave energy is going to get reflected into the klystrons. So what happens is there's klystrons, solenoid magnets, and quadrupole magnets, but they don't show you the wigglers. So what happens is that this creates a free electron beam in a circular rotation, right? So on the top of there's these open windows that release synchrotron light because they're letting the light out. And the synchrotron light, I said the byproduct is Bremsstrahlung radiation that will separate positrons and electrons, because positron never died. It was always with the electron. And what happens here is that, like I said, they reconnect and create positronium, and this is a positronium effect, and it's a really exciting effect. So, as you can see, it's a quite strong cavity there.
Protons.
Yeah, and so like this is like, I wish I could take you through this properly because I have the patents for all this. Every piece of it, I have the patents for it.
How would you excite protons with positive charge, I guess?
No, what you do is when you're ejecting the free electron laser, just after, I believe it's after or maybe before either the magnetic yokes, or if you have electrostatic yokes, like they do in televisions, right?
Oh, EMF fields, squeeze them together.
So what happens is that you seed it just before the lens, and you shoot it out. Then the electrons are now doped with the protons. And generally, you want to use something like a metallic vapor. So, like if you had like a spark gap, and just released a bunch of metallic vapor, and then you can use that. Like something like gold ions or.
Where's the positronium in this? You can't drop a word like positronium and then not have it in this following picture.
Well, positronium happens from the Bremsstrahlung radiation. So if you see the little lights here, it says light bulbs, right? For synchrotron radiation.
Yeah.
Well, that creates Bremsstrahlung radiation as well. My bad. It's like the byproduct. Yeah, you see the number in the top corner there. You type that into the NASA website, and you'll get it. You can get it from them. But anyways, go down because there's more meat and potatoes here. So look at how it works. Okay, so it is electrostatic repulsion and attraction, fellas. You get this now. This is the missing piece. Everyone says it's only plus and minus. No, it's not how it works.
There's a third. And the third, when you get the third in there, it creates the scalar moment. Is this correct, Karen?
So what are you saying? It's not. What you're saying is it's not plus and minus. It's plus or minus.
No. So what I'm saying is you charge the craft positive or negative. Is it positive? Yeah. And you shoot out proton beams on the ground, as you see here. You might have to go down just a little bit there, Nate.
You shoot up proton beams from the ground into the sky.
No. You shoot the proton beams from the craft to the ground.
To the ground.
It's so frightening how this is cut
and
off.
Making it positive. So you're creating a repulsion force, but you're going to shoot your negative energy into this electron cloud. But a lot of people don't realize, until even Lake Mirabo didn't realize until later, that when you shoot up an electron beam, it doesn't turn into a cloud in umbrellas. So what you needed to do was you needed to turn into a free electron laser, so it shoots it out like a laser.
Oh, that's how they make power, you're saying?
No, I'm telling you, this is how you create flight.
or
buoyancy, or whatever you want. Electrostatic attraction.
That's how they use the laser and they hit the planet with it to get their direction.
The proton beams, these are free electron lasers that are seeded with protons.
Free
coming from that ring around the craft.
Yeah, I've never messed with lasers,
it's a rotating ring that accelerates the laser light for when you need it, and then you shoot it down.
So they're just using high intensity light to excite the protons or whatever.
Synchrotron light, synchrotron radiation, whatever, yeah. And then they're beaming it like lasers, because you can create a free electron laser with the synchrotron.
What's the purpose of the free electron laser, though? What is that purpose?
And then a wiggler. And then you beam it out with a yoke. And then you seed the yoke, or seed before the yoke, if you want it to be a proton beam or electron beam.
And that's how they got the craft to push left or move this way.
That's how they're creating the electrostatic attraction. This is like a electrostatic linear motor.
Kind of like touching a balloon
This is space charge though. This is so it's
So, like rubbing a
space
sheet,
charge.
like rubbing a sheet and touching the balloon with
Yes,
it.
this is all that kind of stuff. Except that
Right.
we're using a lot more power.
It's a
A lot
direct
more,
pulse.
ions. So, like, if you understand, free electron lasers will create tens to thousands of Tesla as a byproduct due to
Static.
positronium. Right? That's the after effect. Like it's literally
So are you
creating.
saying static electricity is filled with positronium?
No,
So
I'm saying static electricity creates magnetism.
Yeah.
That's why when we use magnetic products that tune to only a certain magnetic frequency, we only get so many Tesla out of it. So if we
Right.
create rotating ions, we create multi-Tesla fields. I have all this is all
And you
on-
do that with the high potential static field. You're saying. Right.
No, well, what I'm saying is that the because you're beaming it out as a laser, so the acceleration is creating a magnetic field, right? The velocity itself,
The laser itself is
electrostatic
accelerating,
ion
creating a
are
magnetic
creating
field.
a great Tesla field because there's nothing magnetic that is retarding it. So for example, if you used iron would tune it down to its field instead of allowing it to be multi-Tesla.
Makes sense.
Right? Because it's all about
And
the
the
material.
laser has nothing tuning itself down. You're saying.
And like I said, I have the patents for this by Angels.
And you keep your tuning with the laser that way, I guess.
Yeah. So and that's Angels in German.
So they use the laser to do
Yeah.
the pulse and get them to sprint that way or whatever.
Well, and I scroll down.
So it happens when the laser
this
touches
is
the
how
ground.
you
then
lead
it
your
pulses
craft
after?
around. So you have this guy in space, which is the old Neo cylinder, which I'm going to show you a video on. And exactly when you watch the video, they're talking about at the very end, the little tidbit is we're beaming microwave energy down to the earth. That's all they say.
Doesn't sound too complicated.
No, it doesn't. But they don't say that they're going to create flying saucers that are going to fly around and we're going to control them and tell you they're aliens. But anyway,
It sounds to me like it's not too complicated to the point
that's
where
important. Go back
definitely
up there.
people know
That's
about
far
it
more
and
important
have
than you can
used
imagine.
it.
So what this ship is doing is it's beaming the space charge here. So you'll see a positive craft here chasing a negative cloud. Then you see a negative cloud getting repelled. And then you see it's chasing the positive cloud. Like I said, this is all about attraction and repulsion.
So they use the clouds to navigate, to move around.
Yeah, but I do have a space charge cloud patent from the 50s that show you that they were working on this. Like this, I guarantee you they had this in the 70s. And this is probably what they were beaming down and that hit all those Brazilians on the island. You know what I mean? It's probably just free electron lasers that they were flying these craft around. And then they had to come up with something, so they probably threw a guy in a weird spacesuit. Anyway, so no, seriously, this is how it goes. That's by programs. They got to wing it. You know what I mean? Like they're just.
Hey, look, I'd say the Swedish probably are using this in secret up there in their mountaintops there.
No, they did it long before us. Yeah, they did it in the 1800s. I believe they did.
You ever been to the Netherlands? That place has got so many languages.
They got mountains, dude. That's where you can extract the energy you need to even test the stuff.
You could hide anything over there.
Yeah, I believe the Swedes did this in the 1830s, and the war ruined it for us. In the Civil War. Anyways, so because people had vested interests like whale oil and steam, right? But anyways, so just like today, but in other words. But anyway, so you can see the force lines are going this way. The energies are attracting each other, so they're fine, and that the cylinders beams are controlling the beam ships. Okay, scroll down.
How do they discharge the laser into the craft for its propulsion?
They don't.
They
can because if you remember, I explained to you Nikola Tesla's one-wire circuit light. If they were able to use that one-wire circuit light to create the laser, free electron laser, it will follow the tuned coil that it's tuned to.
A one-wire circuit light.
and it'll follow it with cold neutrinos, so it's faster than light, practically instantaneous. So there's no way it's going to lose the craft. It's attracted to it,
Right.
tuned to it, just like a radio. Like I said, they're flying
Yeah,
radios.
yeah. It's got no ground. You didn't give it a
The
ground.
flying radios flying on their own antennas. They're like a linear
You-
train that's made into a radio that takes itself to another location by an antenna signal instead of making a linear.
It sounds
track,
to me like they're
they just
spinning up,
made it like a tube.
static
They just
generators
up another
to.
tube.
It sounds to me like they're spinning up, Van de Graaff, type generators. Those don't require a heavy
But that
torque.
retarded. But anyways, go down.
Those are very easy to turn. Those things.
Yeah, all right. So they're showing you how the lasers work. At the bottom of the craft, they are actually explaining where they would shoot the laser and beam it off the bottom to the earth to another craft type of thing. But anyways, keep going down. That was way further up, but don't worry about that. The pictures suck. Okay, so here's another one that explains to you how this thing could fly on its own. So it creates, a giant. As you can see, that it's creating an E-beam in front of it, which is electron
EVOs.
beam, or the free electron beam. Free electron laser beam, and then it creates a cloud of protons in the back, or charged ions, particles, whatever, right? And then it separates, and then it's going to fall in one direction, right? And then you can see there's a differential in order to create a propulsion, right? In order to create a force, because you need a differential in order to create a force. It's just more
Right.
work.
You
Can't
need a
create torque on
differential
anything
potential
without
to go
differential.
either or one or direction or the other, right?
Yeah. So scroll her down. All right. So it shows you there. You have positive craft, negative electron cloud, negative craft.
Yeah. If your
proton
craft is
cloud.
positively charged and you got negatively charged, or
In
anything
between the
that's
planet and the
less
ionosphere.
charged than you, you're going to go to that.
Yeah. So you're starting to get this, right? Like this is how they were doing
It's
it.
pretty much the balloon,
Well, It prevents also too, like if when I go through the document,
I'm not talking about a air balloon. I'm talking about a balloon that that you have at a party. The plastic balloon that has a static on the outside. It's pretty much that right there. That whole thing.
All right, keep going. So because they end up talking about the solenoid plasma shield, which is it's where Lake Mirabo even got a lot of his ideas, but. As you can see,
by rubbing the balloon up, you positively charge it, and then you discharge a stun gun next to it, which electrons, which is a negative charge.
Yeah.
And you see it's going to come to your stun gun, or if your stun gun is putting out a higher charge than your balloon is, then the balloon's going to go the other way.
No, that's wild. I never saw that. I never really paid attention to that open cycle one. Cool. Scrolling down. There's some gooder stuff or better stuff. I wish I could show you his copywritten book live, but that I'd probably guess pinged. Okay, that's space stuff. That was the idea of how they were going to get a lot of stuff into space so that they could just create a beaming station.
Sounds like these craft explain where these EVOs are coming from.
Oh no, these craft have been made, and all of us have been embarrassed, lives ruined, just to keep this secret. And it's right here in this NASA document.
What's the difference if you paid the same price to fly in this craft to go overseas and instead of a plane full of petroleum?
Yeah, if you keep going down, there's actually better cylinder stuff in space, because I want to show you how the propulsion works in space. Because everyone's like, a vacuum. Yes, this works in a vacuum.
Right, and this is like
anything for safer travel.
Back up. One more. Okay, so one more up. Just want to get to the title. Okay, yeah, that's a terrible looking. I wish. God,
I guess you would have to discharge yourself if you were on that craft, if you wanted to ground out,
Well, yeah, that's why you have a Faraday cage that bleeds off into the electron gun. But anyways, so scroll down. My bad. Go down again. But that picture right there where the cylinder is, I wish we had a better picture of that. But I bet you that looks good in color.
So you're saying,
but anyway, so here this is the militarized O'Neill cylinder that they were making. So this was all militarized. This is how it was supposed to be. This is all, like I said, you saw the document. This is 1983. And that's when the document was given out. That wasn't like, oh, we have the billions of documents we made before this. You know what I mean? Like, so anyways, this is the most important picture. If you can blow that up. I think there's it's plus sign somewhere around here. Yeah. Scroll up a bit more. Yeah. There we go. Okay. So this shows you how they attract and repel the craft. So like the tractor beam and the repulsion beam. So you can see that you see the S core is negatively charged. It's attracted to the craft. And then the space shuttle that's leaving takes off. And they can do this with the beamed energy as well, which is even more fascinating. But they don't. I don't think they show that in this picture or later on. I think I have to go to. I think it's in his book. But anyway, so they show like how they can beam the energy and destroy a threat off of. There's flight mirrors that can be turned.
This is
satellites
like all
that can
the
be
same
around.
as Tesla's death ray gun thing, right? And that they almost similar depictions. No, same technology. Yeah.
These static fields look pretty intense. I mean, it sounds like that craft in the 30s that everybody thought was a UFO. They were shooting
You know what
at
it
it.
reminds me of?
Or bouncing off of it.
It reminds me of CRT wars in space, in the vacuum of space.
Cathode ray tubes.
CRT television, right?
Cathode ray tube,
yeah, cathode ray tubes, yeah. But instead, space is the tube, and you could just do whatever you want, right?
It's like a high-powered diode, you know.
But anyways, that's exactly why they create the vacuum around the craft, right? In order for the
it's making DC
like the lofty materials to take effect, you need to create a vacuum around the craft. That's why Bonston worked on that with T.T. Brown. And you see it like when T.T. Brown in his notes, he talks about like how when he created the lofty material, he had to have it in a vacuum. He had to heat up the bottom plate. He positively charged the bottom plate. Then he negatively charged the top plate. And what would happen is the lofting particles would float and the remainder would stay at the bottom. And he created another way with centrifugal force where he rotated a bunch of beakers that were full of water and the material. And what would happen is he would rotate it, then he'd push it outside when it was cold because in the winter, and then it freeze, and then he would take it out. He would, and this is in the electrostatic isotope patent for Canada. He would take out the ice, and then he would break it, and whatever followed centrifugal force, he would remove, and then he'd keep whatever floated above, because he knew that would loft through centrifugal force. And the planet gives you centrifugal force. That's legitimately, like, the centrifugal force is what's creating gravity, right? It's creating electrostatic friction, which is creating electrostatic
right.
Which holds us to the planet.
If you move in the opposite direction, if it's flat or round, it don't matter. It's got to be spinning to some degree.
Yeah, like what I believe, like a lot of these craft,
even if Earth isn't spinning, something else is. You know, like whatever is around Earth is spinning. Something is spinning out there.
Well,
so centrifugal force exists. You know, and it's going to transmit everywhere.
But anyways, yeah. Keep going now.
So I'm just saying, like, you know, even if there's no centrifugal force on Earth, which is impossible, and Earth is not the source of centrifugal force, there is centrifugal force out there, and it's going to transmit to Earth and make Earth move.
Earth is rotating. There's centrifugal force.
Yes, I know there is, but there's people out there that say it's not. So, okay. And it could be moving very slow, but it's still spinning, and that's enough.
Well, we're spinning through the galaxy. We're spinning through the universe. We're spinning there. There's a lot, and everything's following the right-hand rule. I think I mentioned this to these guys, not these guys, but a couple other guys earlier, is that like the planet Venus, right? It spins in the opposite direction. So when all the left-handed materials beyond there, wouldn't that be why Russia went there?
Well, the
Like, and
atoms
they
will
talk
be
about the
spinning in the
Venusian.
opposite direction, like you said as well.
That's
Yeah, they
very
also talk about
fast.
the Venusians keeping the planets in orbit, and like these Venusians would, like, how could they have craft that would do that? Well, if they had something that spun in the opposite direction of everything else in the universe, they'd have, and it's a high pressure material because there's a lot higher pressure on that planet. It would take a little amount of energy with that material to create a floating device.
Right, because everything's spinning, even the atoms are spinning in the opposite direction, and they're not going to
Yeah,
want to
so if you
go
brought that
in
to
your
Earth,
direction.
yeah, because it's following the left-hand rule instead of the right-hand rule, like everything else in the galaxy. Except for, it's weird because I believe the planet just only rotates left, whereas the rest of the planet follows the right-hand rule, I believe. I can't remember. I can't recall that anymore. I'll have to look up Venus again and its rotation. But regardless,
and it's
all the
permanent.
right-hand
That
rule
rotation is
planet,
permanent, right?
yeah, but if for some reason that is the fact, though, that means it can literally separate itself but still follow the right-hand rule of all the other planets. It just separates itself from because it's creating a vacuum and then a charge to it.
Eventually, it's going to have to spin the other way wherever it ends up. But who knows how long that takes? In the meantime, it's pretty.
Yeah, I was actually
handy.
watching this quantum. They found quantum in a vacuum tube with a little bit of mercury, and it was explaining these elastic. I have to watch it again in order to remember the names of this stuff.
Basically, the spring technology,
but anyway,
spring.
The electrons would act on the atom to create ionization, and I believe that these lofty materials do that. Oh, don't close it yet, Nate. We still got. Oh, is that over?
Yeah, I said it was at the end.
Okay. All right, hold on. Let me see if I can find another good document. All right, because, gosh, I wish it wasn't so late. I gotta go work tomorrow. Darn lives.
In theory, that the sand from Venus.
I also have to work tomorrow, but this is awesome. My brain is exploded with knowledge, which you're gonna have to rewatch several times just to compartmentalize it all and decompress.
Do you remember way back in the day when I told you, I'm like, yo, I'm gonna tell you all about space charge, and then it's gonna go right into the UFO stuff, and it was all about electroculture?
Yes.
Do you remember how I was showing the cloud seeding technology using steam and charged particles, and then how they were able to change the clouds and how their clouds were dropping different space charges on the ground through rain?
Yes. Yeah.
That's everything we looked at is doing with that. Like that, what we just looked at. Because literally, it's just the same type of charge, it's just transmitting energy differently.
In lasers. Okay.
Yes, but you see, I have other patents that show back in the day that they did this with electromagnetism radio waves as well. But they weren't able to do it like Tesla, because Tesla was able to go at a super high frequency and have no losses. Right? Because he would just transform it would transform itself back in a different location. And then you just using your primary, you tune it back into usable energy.
Okay, so Taryn, it's like this is several generations worth of people's lives and development, and like generations of craft.
You have to follow history in order to actually find out the truth. What is classified?
The Tesla coil is the one
actually
wire.
allowed. You actually have to literally go back to 1700, like I did. I went back to the 1700s. I went and looked up the books. I found the best one was him explaining all the 1830s. It was that book because it had all of it. It had the pyroelectrics and everything, which explains all the flame jet generator and all that stuff. Like, it's all there. Actually, what's his name showed it? That one guy that. What's his name? The guy that got in trouble because he had a different kind of account somewhere else doing adult stuff. What's his name? Yes.
Cook.
You remember he went through all that old stuff?
Yeah, oh yeah.
I have the legitimate books.
Yes.
I actually have the textbooks of the student one and the actual engineering one.
Oh wow.
Yeah, I have that
Okay.
all on. I have that. I gave you the access to that drive too, but it was a different one.
Okay, I'm gonna have to go through that. We got to do that as a project.
Yeah, actually, I like I said, I'm gonna have to actually sit down with you guys and go through everything so that you guys can just share it because it needs to get out there. This is like I said, we're reinventing the wheel over and over and over again, and it's getting sad, and we're learning less, which is even worse. Because like I just explained to you guys, 3 different antenna systems, 3 different electrical systems that don't even, but like the 3 ones I showed you don't even hook up to Hertzian yet. Because remember, there's Marconi, Tesla, and Alexanderson system. And then there's Hertzian. And you guys are all working in Hertzian.
Right. So
you have
there's
all
just
these
so
other
much.
circuits and different systems and different field antennas. Like, the 1947 field antenna. OldMan builds. You have to look that up.
Okay.
1947 field antenna. It's I believe Periscope did it. I believe he's the one that brought it back. It might not have been him. It could have been someone else. I believe it's from the National Archives originally. But
I think I know the one you're talking about, and I'm excited if this is the one that I think it is.
yeah, it shows the electrostatic field and the magnetic field, and right after that, because you'll see in the null zone, it looks like a flying saucer, and yeah, and you'll see like why they took out field engineering and made atomism. It's to keep us surface dwelled. They have no control over someone. They can't tax someone if they're in space, international waters, or international space, whatever you want to call it. Not yet, anyways. I'm sure they will, because once people get out there, they're going to need a way to governance piracy, because no one wants to be raided by a pirate in space. That'll be the next thing. That's why I don't understand why the military hasn't upgraded their shit, because why don't they? They have the entire solar system to suck back resources
police
that they want.
They'll have space cops.
There will always be space cops. You got to have space cops, or you're going to have aliens coming in and scooping us up. I'm not talking about human aliens.
Space judges. Space utility workers.
Oh.
It's all there.
All right, guys, it's getting late.
Yeah, I know. Sorry for stealing the show.
Yes, I got work as well, for sure.
I got a lot to share, guys. I mean, I have so much to share with you guys. Is unbelievable. I could show you.
We will keep doing this, and we will, like...
Well, I hate that I have to navigate through Nate, because I would just want to go click next. I don't know. I feel like, even though it's great having you do it, but I mean, it's just my computer's so slow.
We'll do it again very soon.
I gotta oopgrad it.
Yeah, I'll do some edits as well. Much love. Appreciate all this. Great hangout today.
Yeah, I guess till next time, guys, because like you said, it is getting late, and I got to go to bed in about 15 minutes.
Yeah, we're all about there.
Appreciate it, gentlemen.
We're going all day.
Right? You truly have, Nathan. Like, frick, you were up at like
okay,
midnight,
guys, so
1 a.m.
1 a.m. I get up early to test because I have to do it at nighttime.
Yeah, that's when all the aliens get to see you.
We'll see.
Yeah. Oh no, we got to dampen the field.
All right. Well, maybe I'll just. Actually, nah. Up to you guys. If you want to post the link for people to do an after party, but if you're all going to bed, I don't know. I got to go to bed because I got to work. So, love you all, and we'll do this again very soon. Probably tomorrow.
Love you, Bernie. Appreciate it.
Hey guys, I'm out. I'll see you guys all later. Thank you guys for all coming.
Yeah, thank you, everybody. Thanks, Nathan.
Excuse me. I just want to say a big thank you to Shawn for coming in as our guest, and Ian, thank you for showing up today.
Yes,
we're gonna have to have you,
Shawn.
we're gonna have you back on with everybody because I think we can have a great conversation with everybody. It'd be awesome.
Yeah, you're awesome, Shawn.
Yeah, I look forward to it. Brilliant.
Right on.
Thanks.
Thank you.
Thank you.
All right, Sharon. Thank you.
Thanks,
No
Ben.
problem, mate.
Yeah, no problem. Have a good night, guys.